take it real soon. You know we got what you need, baby, so take it real long.
Exclusive insights from Siemens, tightening funding for startups, and a look at Australia. These are today's top stories at Formnext News. Live from the fairground, we bring you the latest updates and essential stories. In an exclusive interview, Dr. Peter Kuerda, Siemens board member, and host Frank Jablonski discussed the company's strategic perspective on the AM industry and its future outlook. Kuerda highlighted the high maturity level within the AM and fantastic growth expectations of up to $40 billion by 2030. He identified the automotive and phone sectors as promising growth opportunities, while also pointing to the defense industry as an attractive area for AM solutions.
And in Germany, because this is very often it's a very German conversation, we have this very ambiguous feeling about defense. Defense is absolutely important and it's crucial for our security. Every country is like that. And so every country is investing massively into defense, as is Australia, as is the United States, as is Europe, and we have this conversation with the Ukraine war. And defense is perfect for additive. Why? You have a lot of high strength durability applications. They're usually not super high scale. They're usually required resilience of supply chains, so you can produce them locally. And then lastly, you have to have the ability to manufacture that over the entire life cycle of whatever you produce. Yeah? And that means usually hopefully, this equipment is out there 20, 30 years, however it breaks. So you have to, have spare parts and all of that. 3D manufacturing is perfect. It's just perfect for defense industry.
During yesterday's morning talk, Rainer Lotz, chairman of the Formnext Advisory Board, along with Dr. Marcus Heering, managing director of the Working Group and Additive Manufacturing Association at VDMA, shared insights into the current state of the AM industry. According to a recent VDMA study, member companies expect the domestic market in the AM sector to remain stable in the short term. Looking ahead, the outlook shifts, with managers expressing greater confidence in the AM sector despite the current challenges. Nearly 60% expect their AM businesses to grow over the next 2 years.
Business expectations are lower. In the long-term perspective is still positive. So if we speak about in 2 years ahead, they are still positive and 80% believe it's growing. But in the shorter term, it's more moderate, I would say. We expect for next year that the American market is growing. We expect in spring the economy will rapidly increase. That will have an influence in additive.
This year, Australia takes center stage at Formnext 2024 as the official partner country, representing its innovative additive manufacturing community. With a growing market across industries like aerospace, medical, and renewable energy, Australia is a driving force in AM advancements.
The heartland of manufacturing also in this part of the world, and we also recently opened an office in Paris, and so a lot of the companies that are doing business here in the region are already working with companies across the different sectors that are based here and or have a really strong presence in Europe.
The current economic situation makes it harder for founders. According to the AM panel Startup Finance and Funding, startups are finding it increasingly difficult to convince investors. In these challenging times, the focus is on protecting existing investments and presenting a more professional approach, even during the founding and pitching phases, to win over increasingly critical investors.
In 2021, money was plentifully available, and we saw in that time that a lot of money does not necessarily amplify the great ideas in companies. Sometimes it's very tempting that you develop a lot of stupid ideas and waste a lot of money, and we see companies failing that have raised hundreds of millions and they didn't go anywhere. And therefore I'm very much convinced that if the river runs low, if the money is not there, people become more creative than at any other time.
Despite the challenging situation, the industry's innovative drive remains strong, as demonstrated by the resourceful approaches of the numerous exhibitors in the startup area. Stratasys, in collaboration with AM Solutions, has launched the Powderies T1 system, an advanced post-processing solution. This 3-in-1 system automates key steps, significantly reducing manual intervention.
And what are the major problems everyone has with powder bed fusion? You get a big cake with a lot of parts in it, and you need to separate the parts from the cake. So the T1 powder is going to put in the cake. It's going to use vibration and compress air to separate the parts from the powder, blowing the powder out, collecting it here, and then filtering it before then it's been moved with new virgin powder into a powder storage container. So it's 3 steps: separation, retrieving, and mixing the used powder with virgin powder. And at the end, you lift up the compartment, you open the lid, and you can take out the parts, which are going to look like this.
Nano Dimension presents a new DLP 3D printer for micro applications at Formnext 2024. Designed with a larger build volume and high precision, it targets industries like electronics, medical devices, and jewelry. The printer is compatible with Nano Dimension's resins and third-party materials, offering efficient production of detailed microparts. If you haven't voted for the Formnext Award yet, don't forget to visit the showcase. Meet the shortlisted candidates and cast your vote for your favorites. Whether you're looking to enter the industry or expand your experience, today's Career Day is the perfect opportunity. Meet top employers, get free career advice, and have your application photo taken.
At UPM Additive Solutions, we are a global supply chain provider that focuses on conventional manufacturing, specifically subtractive, to provide tooling and consumables to the additive industry. We use subtractive manufacturing to produce build plates and recoater blades in various alloys, whether to OEM specs or to your unique additive needs. We also offer the full supply chain solution services such as heat treatment all the way through to testing of the part itself and everything in between.
Yeah, what we're most excited about this year is our new product service offerings. Since we started this branch of United Performance Metals, we started with new and refurbished build plates. Since then, we've been able to add powder supply, feedstock supply options, and even post-print processing.
Our customers really benefit from our services because we manage the entire process but the print. This allows them to focus on their value add, and that is designing exceptional parts, printing them, and scaling their production while we do the rest.
Please don't hesitate to reach out. We're excited to collaborate with you and see what solutions we can find to your supply chain problems.
Anki Interdentalis developed a 3D printed dental splint that uses a water-air mixture to remove plaque from interdental spaces. Designed from a patient's scan, it generates microdroplets that clean all interdental spaces in just 3 seconds, improving dental care for both professionals and patients. Dentis offers a multi-material additive manufacturing solution for dental prostheses. Using the metal powder bed fusion process, it combines alloys such as cobalt chromium for strength and gold for precise fit. This robotic process ensures high quality, dense parts and enables efficient, precise production of dental restorations. Oryx Medicals is developing a 3D printed aortic valve for treating aortic stenosis. Unlike mechanical valves, it uses a minimally invasive TIVI procedure for easier implantation, tailored to each patient's anatomy. The valve combines durability with a longer lifespan, reducing recovery time and complications. Baker Hughes is using additive manufacturing to reduce the environmental impact of gas turbines. By replacing casting methods with LPBF technology, they improve efficiency, reduce CO2 emissions by 38%, and support their goal of achieving net zero emissions by 2050. Ceratizit developed an additive manufacturing process for cemented carbides used in cutting tools and wear parts. Their FFF process reduces CO2 emissions by over 95%, allowing for inner hollow structures. With 100% renewable energy and reprocessed materials, Ceratizit leads sustainable manufacturing. Stratasys promotes sustainable luxury footwear by reducing emissions, conserving resources, and lowering costs. A recent study shows that 3D printing reduces emissions by 25%, material usage by 49.9%, and even electricity consumption by 64.3%. The J850 textile is highlighting additive manufacturing's sustainability potential.
Welcome to the third day of Formnext TV here at Formnext 2024 from Hall 11 and booth D72. I'm very happy that you zoomed in again to our live stream here from the Formnext, when we will bring you the latest news and exciting products and developments from Formnext. Yeah, today again you can expect a rich program around additive manufacturing, expert presentations, panel discussions. Today with a focus on skills and talents. And this afternoon in sustainability in AM. And this afternoon we will have another highlight for you prepared, the awards. You just saw them in the stream. There were a lot of nominees with very interesting topics. And this afternoon we will see who will be the winner. Yeah, but now we want to start into the morning talk with our guests, with our selected international guest here on our stage. And I'm very happy to have with me Nayara Zubizarreta. She's industrial engineer and director of ADIMAT, the Spanish Association of Additive Manufacturing Technologies and 3D. Nayara, very good to have you here.
Thank you very much.
David Adrova Iglesias, General Secretary and Executive Director of the Industry Consortium IM 3D Hub in Barcelona, in Spain.
Yep.
Good to have you here,
Thank
David.
you very much.
And Eetu Holstein, Senior Ecosystem Lead FAME, the Finnish Additive Manufacturing Ecosystem. Eetu, nice to see you again.
Thank you, thank you.
And of course, my co-host Sven Krause. Sven,
hello,
good to see you as ever. Sven has a tea with him because he's a little bit suffering from voice. So
yeah, that's kind of the Formnext illness, you know. I mean, besides the fact that we are moderating all the time, we have so many conversations beside as well. So it's like a 15 hours talk day, and after a while it hurts your voice a little bit.
So here's the same.
Yeah.
Yeah, but being at Formnext, you know, is not only talking, not only hard business, it's a lot of fun as well. And maybe before we start and get your impressions, let's have a look at the impressions our camera team collected at the fairground. So we have a clip with tons of impression, and I'm very curious what they brought here to stage. So I would say, and action.
Wow, a wide collection of products and new stuff. Some old stuff we already know since years, but some were new as well. Nayara, what was your highlight these days? What did you bring in your vision with you?
Well, I think that as it has been shown in the video, there are a lot of different applications that we will find during the exhibition for very different kind of parts for every sector. Every technology is being highly specialized in one vertical, in one niche technology and sector. And this is the fight now for the sector, right? Looking for the right applications where the use of additive manufacturing makes sense, really.
And did you get the one or the other product, or there are some art products here next to the stage? Did you have a favorite?
Well, I have many favorite parts that I have seen.
Won't tell her.
Yeah, in our booth, for instance, we have a company bringing a new disruptive metal technology. Their name is Robalma, and they are able to produce big parts very, very fast.
That's the disruptive aspect, the very fast production?
Yeah, fast production of big metal parts.
Okay. How big are they? What is the production volume?
600, 1 meter. I'm not sure, but quite big for the average.
Too big to carry to the stage here.
Yeah.
That's for sure, yeah. At least if it's in metal, that's...
Yeah. David, I guess you had a busy time as well with IM 3D Hub, but what was your highlight so far?
Well, usually in past Formnext, what we see is always like a trendy application all around, an application that you can find mostly in a lot of booths. And this year, what we see is that there is really a variety of trends, a variety of applications that are some of them already known, and others that are starting to become more and more trendy. So our highlight is that from past editions, there's not just one trendy really application, but already many, which is a great news, and we love discovering many of them all around the halls and making our reviews on which applications we find in which materials, in which companies, in which technologies, and how this variety brings also diversity in the market. So the highlight, I would say, variety this year.
What caught your eyes? There's always the one thing, you know. My eye caught the small kangaroo. Christoph Stücker had the small kangaroo here, and I want to have one of these. So that was my highlight.
Okay. I would say that from my personal point of view, there's something that's always captivating me is like the Stratasys technology, where they print on textile. That's something that we've been seeing for many years ago already, but every year more and more, there are more applications on that specific technology and materials that brings also very creative stuff on the table, and you can really get inspired on what the 3D printing technology can do, and in also not only technical applications but also in creativity applications. So that's one of my favorite.
Okay. Etu, did you have besides the socks from Formnext, did you have a very special experience here, or maybe it was a talk or some new partner or something? What was your highlight?
Yeah, for me it's been I've been at our booth mainly. I haven't had time to go around that much, but we have met so many people, new connections, old faces. So my highlight has been that the discussions we've had with people. But something that caught my eye is the large-scale AM, the large metal parts and large polymer parts, as well as we have printed some furniture and stuff at our booth. And when I'm walking around, you can see a lot of big-scale stuff coming here that maybe hasn't been there in that much earlier years. So that has been really interesting to see large-scale polymer AM entering here as well more and more. So that I would say that has been something interesting I've seen.
You also mentioned the variety of products, of industry sectors. Yesterday we had some facts and figures about the industry sectors on stage. I cannot recall them all, but from your personal perspective, which sector do you expect being the most growing one in the upcoming years? Where is the most fire in Nayara?
I would say maybe aerospace and defense sectors are working a lot in the last years on additive, and they are finding very interesting applications. And also in medical sector, which is very personalized parts. So there is a lot to do yet in every sector, of course. But I would say that those are the ones that are making big efforts now in order to find new solutions based on additive manufacturing technologies.
And with highest expectations for the future, from your perspective?
The
growing expectations.
Yeah, they have growing expectations.
That's what we heard already, and we discussed if defense would be prior or medical. You were very diplomatic and named both. So
aerospace as well, I said.
Okay, yes, aerospace as well. Yeah.
Well, I find the same thing more or less. For sure, aerospace has been one of the most traditional sectors where additive manufacturing had a great impact and a great adoption and implementation. For sure, in coming years, we feel that there's going to be a lot of attraction in implementing additive manufacturing in defense. Also, political plans, we feel that will shift towards this pipeline of adoption in different segments. We have strong collaborators with also. They feel the same way, but also the medical and healthcare field is one of the I would say, growing markets and growing fields in adopting additive manufacturing technologies, and also thanks to the efforts that we are doing from both technology providers in developing technologies, materials for the medical healthcare sector, from associations, hubs, consortiums, supporting the adoption in the healthcare sector, in hospitals, etc. And also from the medical companies. We've seen huge interest in visiting Formnext, in being in Formnext, and even exhibiting in Formnext next year, because they see that this is also a growing market in that field, and they want also to be present in the first hand, and that's, I would say, both, as Nayara said, we can see that usually those are the most growing sectors nowadays, at least from the ecosystems that we know.
From your perspective, the same?
Yeah, defense, unfortunately, that in the world we are living now, so defense is putting a lot of effort and money in developing new capabilities to adapt AM. What we try to help is, of course, that companies can adapt AM more in like more traditional way, like from the machine builders and stuff. But yeah, defense, there is a lot happening at the moment.
Sven?
I didn't want to add something because we got that. So it's approved. It's military, aerospace, and dental or healthcare. This is the main topics. What I'm interested in, I mean, we have this one-time opportunity that we have the Finnish market here and we have the Spanish market here. You know, the thing is, I usually, when I talk to people, I get impressions from the US, from China, from Germany, of course, a lot, because I have a lot of German partners. So what would be interesting for me to get like an overview of Spain. What is the AM scene there? What are the focus topics you're talking about? How does collaboration work? And the same for the Finnish markets, because we never have the opportunity to hear some insights from a specific market. I don't know, as we do ladies first, probably Nayara, probably you want to explain us about what is Spain and AM about?
Okay, in Spain, we have 105 members at the moment, so the ecosystem in Spain for additive manufacturing is quite strong. We have all the value chain more or less covered. We are a community that we cooperate a lot. From ADIMAT, we organize different events, B2B meetings between our members. We push innovation and cooperation between them. We organize also a trade show in Bilbao together with the Bilbao Exhibition Center every year. And our goal is to accelerate the implementation of additive manufacturing in industry. So we are talking about technology, about new developments. We are talking about the need of talent, about new people to join the sector, and with all the difficulties that we are having at the moment for that. We are talking about cooperation, we are talking about digitalization, robotics, implementation of AI in the additive manufacturing, so many topics. So it's really interesting what's going on now, but still a lot of work to do, because this is a niche technology. The market it's small in Spain, and we are working to raise awareness in industry and to show them what can they do with additive manufacturing technologies. We develop business cases together with our members and show them to other industries in order to give them ideas on how could they adopt the technology. So that's mainly what we are doing.
But as David mentioned fashion already, and I hope this was not for purpose, in order to introduce Spain as the fashion country. So what is the one thing you would put Spain into as a focus in additive manufacturing? Like, I don't know, we are heavily focusing, of course, on machining here in Germany, and healthcare is a big topic here. Is it in Spain the same diversity in topics as we are already in international technology, or probably David, you?
Well, in Spain, there's a specific market, just to mention one, but many. That would be also footwear. Footwear, we know we have a huge network of companies, of technology providers that are working on footwear applications. From universities also, where we implemented a specific course and degrees and master degrees about additive manufacturing. We see a lot of projects regarding footwear. We have some examples in the booth of those projects that we supported. And there's a huge, I would say, movement to implement or to use additive manufacturers to create more, not only creative footwear, but also functional. So we have some examples from, I would say, climbing shoes, personalized, 3D printed. We also have examples from cycling shoes, for sure fashion shoes, and casual shoes as well. And there's also next to us, where we are located in Barcelona, there has been the HP manufacturing plant with many multi-jet fusion machines, and one of the main applications that they were printing were footwear applications. And now these facilities regarding footwear are increasing their production also in the footwear market. So this is one of the ecosystems, apart from the medical and healthcare, as I said, that we are supporting a lot in adopting additive manufacturing technologies. That's what we say.
I would also.
Oh, sorry.
Yeah, I would also like to add that we have a very strong industry. We also have an association, a very important association for machine tool builders. We have very strong companies selling machines all over the world. And therefore, we have a very strong and cohesioned industry around metal parts as well. So this is another point, maybe industry-wise, that I would like to add.
So we don't remember you only for the shoes, that's for sure.
Yeah.
I got that. Itu, a quick description of Finland. I mean, if I come up with a cliche, I would say we were talking about furniture or the chair. That is something, if anything to do with design or interior design, I would put Finland as one of the first three places. But what are the key topics of additive?
Maybe the key topic is at the moment sustainability, and we've done some research on utilizing different LCA tools, and you get different numbers depending on the tool. So the data is really that you need to have the data to be able to calculate the LCA or footprint of the printed part. So that's something that we are working at the moment a lot, and the companies are also putting a lot of effort there to understand really that when does it make sense to print something, and when does it not make sense to print something from sustainability point of view. So that's something we are working heavily at the moment.
That's the same topic for you, David. You attended the AMGTA. I saw in your LinkedIn profile.
Yep.
So how important is sustainability for you?
Well, we are partnering with AMGTA, is one of our main ecosystem partners in the industrial consortium that is the IM3D Hub. And what we are trying to do is also to partner to deliver these more and more sustainability impacts, insights into the business cases, success cases that we provide to the companies, not only just to promote the impacts of additive manufacturing between us, but also to provide, let's say, impacts or justifications for those leaders of the companies that are working with us, developing projects, so they would be able also to justify from another perspective also to their top management that additive manufacturing has even more benefits rather than cost reduction for sure in several applications, time reduction, or the typical additive manufacturing benefits. So we are partnering to start integrating this sustainability perspective in all our projects since the very beginning. What we do, we need to collect from companies in order to do so, and in that case make a bigger impact talking about the sustainability benefits that additive can bring into the projects and companies.
And there is another thing you all three have in common. You want to work more closely together in Europe, right? You try to get your associations with the German and other European. I remember last year you said that you want to work more closely with the Danish hub and so on together. What is the status here? What is the progress, Nayara?
Yeah, we in the case of Adimat, we are already working in a European network through SESIMO, which is the manufacturing association, European Machine Tool Builders and Advanced Manufacturing Association.
From the subtractive world.
Yeah, and we have a working group on additive manufacturing with other European associations, and also we are in contact with hubs like AM3 Hub, and we have been in contact as well with other forums or associations or organizations that are around additive manufacturing, because we want to strengthen our connections and work more coordinatedly.
And what are the goals you want to achieve by working together so closely and united in Europe?
We want to put together all our concerns or all the needs that we know that our members are asking for, and try to push it from another perspective, and also make it known in the governments and in different to the European Commission, and raise some other levels that can help to push additive manufacturing as a key technology for the future.
Yeah, that was my expectation. That when you are united, you have a different voice. Your voice is louder to talk to European government, for example. Yeah.
Yeah, this is what we are working in now, and we want to strengthen this kind of collaborations. So we are in conversations also with other groups.
Yeah. And also, it doesn't make sense to invent the wheel again. So if someone has had some best practices with the members and they see that this has helped companies in Spain to identify parts or apply AM more, so why don't we use the same methods in Finland and vice versa? So it's really about sharing the knowledge and helping each other out. So that's what I also feel. In addition, what Nayara said, that to be together is more, we are more powerful.
Yeah.
That's it. At the end, we have not so much time left, but there is, I heard there is a secret we can unveil here. Is it true that Spain will be partner country next year?
Yeah, I think so.
Yeah, you think so?
Exactly. We found very interesting all the guest countries on Formnext from last years. Thanks to that, we were able to discover like great associations, organizations, what's happening in other countries. It's a great spotlight where to learn from all other countries what they are doing and connect each other. So we are hoping also to have this high speaker in order to get more or deeper known the Spanish market, ecosystems, etc., and what we are doing in additive manufacturing. So yeah, that's why we approach in order we knock the door in order to become a guest country next year.
And Frank, very important for you, the whole industry stage will then be moderated in Spanish.
Yeah, that's Hola, ¿qué tal?
Great.
That's why I'm already training every day in order to be capable of doing that.
Yeah, very nice. Great. Yeah, thank you very much. Now now we have that in the world as well. I hope that will be a very successful REST fair for you here, and next year especially with Spain as partner country, coming from Scandinavia to Australia and back to Europe. Perfect. Thank you very much for having you. And thank you very much, dear audience, for visiting, for being with us, for watching us. And now we will continue after a short break with our next expert insights.
AM Craft is an EASA certified supplier from Latvia specializing in polymer additive manufacturing. They provide 3D printed interior components for aerospace to solve supply chain issues, backed by a global production network that ensures timely deliveries. Their digital warehouse enables the instant reproduction, solving future challenges as they arise. AmSite revolutionizes quality management in industrial 3D printing using its AI-powered software solution. By automating tasks and optimizing processes, AmSite reduces quality management costs by up to 70%. With its streamlined approach, it sets new industry standards for both efficiency and cost-effectiveness. Axolotl Bioscience created tissue print Xeno-free bio ink designed for 3D printing human tissue models. It ensures 90% cellular viability and works with a variety of delicate cells. Compatible with multiple bioprinters, tissue print saves time and reduces costs, offering a reliable and easy-to-use bioprinting solution. Microfactory specializes in resin-based SLA 3D printers with fully automated MSLA machines. These printers simplify printing, washing, and post-curing. They deliver precision, speed, and flexibility for dental models, audiology, and more. Cloud connectivity and scalable automation make production more efficient and reliable. Supernova Additive offers viscous lithography manufacturing technology capable of processing materials with viscosities up to 1 million CP. It enables cost-effective production of short and mid-sized batches without the need for costly molds. VLM unlocks new material properties for industries like automotive and aerospace, using both rigid composites and elastomers.
Welcome to Bosch Advanced Ceramics. Let's be innovative together.
Bosch Advanced Ceramics is a leading contract manufacturer in additive manufacturing of ceramics. Additive manufacturing of ceramics brings new benefits to the customer in terms of design, because previously with conventional technologies, the design was very limited, and now new possibilities open up. I would like to talk about the terminal head, a part that is used in industrial application and that we're already producing in series production, right around 8,000 parts right now. The most important feature are the material properties of that part, because it's used in industrial applications, so the material properties have to be on the same level as the customer is used with conventional manufacturing.
There are many industries who are already leveraging the benefits of advanced ceramics. To name a few, semiconductor, medical are the early adapters for this technology. And the reasons why they are doing it is high requirements on the products. And they are making good use of this technology.
Bosch Advanced Ceramics is having decades of experience in manufacturing of ceramics, and we're leveraging that experience to additive manufacturing of ceramics. And we're already having 10 years of experience working in that field.
It's a very innovative technology because it brings benefits of sustainability with it. This means that the customers, they can reduce their time to market, and also we are using only as much material what is really needed, and having long-term experience in additive manufacturing for almost a decade, we are the right partners when it comes to the series production.
We accompany our customers along the whole process chain, from material selection to the final ceramic part. Visit us at boschadvancedceramics.com.
Welcome to our next highlight here on industry stage at Formnext 2024. Today we have the topic skills and talents for you. But before we start with our next session, I may have the one or the other hint or tip for you. In hall 12.0, in the booth number E22, you can find a free job application and photo shoot today until 4 o'clock. And if the one or the other is interested here in the hall or at home to hurriedly come to the exhibition, there is a direct exchange with potential new employers at the trade fair and a job wall to find vacancies, and even a free career consultation today until 4 o'clock in the afternoon. So if it's interesting for you, make sure to step by in hall 12.0 booth E22. But now we want to start our session here, and it's time for lessons learned. Lessons learned is always good. You know, nobody loves to make the same mistake twice. And the lessons learned we will have today will be brought to you by Hayden Quinlan. Hayden Quinlan is the Senior Program Manager of the MIT Center for Additive and Advanced Production Technologies, APT. Since 2016, Hayden has co-led MIT's industry-facing teaching efforts in additive manufacturing, and today he will present lessons learned from 10 years teaching additive at MIT. That's a lot of time, so the stage is yours. I hope you fill the gap, 10 years in your short presentation. The stage is yours.
Great, thank you so much, and thank you so much everyone for having me. Thank you for coming to this talk. Anyone who's heard an academic talk before knows that we tend to talk way too much, so I'm going to do my best not to run over time, but please forgive me if I go a little long-winded. So as Sven said, my name is Hayden Quinlan. A little bit about me. First and most importantly, I like to put embarrassing photos of myself on the slides. So here's one embarrassing photo of me wearing a bunch of PPE that we made during the pandemic. But simple overview, we spent 10 years teaching additive at MIT. We do that in a lot of different ways, online and in person, as I'll explain in a minute. And I do other things, lead MIT's industry engagements with the additive industry, as well as do some research projects, especially on process cost modeling and some particular applications focused in the infrastructure sector. Again, just a little bit about the program, just so you know what it is. I'm not here to market the program to you, but just to say that the center that I work for is really focused on translational research, on taking basic research, good ideas, and converting those into commercial practice, right? Trying to overcome what some folks call the valley of death, and we do that through advanced facilities, we do that through application-focused projects with industry members, and then most importantly, or maybe most pertinently to this talk, is we do that through workforce training programs. So what courses do we have? You're going to notice that I don't have a link to any course here. I'm not trying to market to you, just to tell you what they are. So we teach both online and in person. In person, we do that at the undergraduate and graduate level, teach MIT students. We also have training programs for industry, programs that you can sign up for and pay for with a credit card that we run on an annual basis. And then we'll do bespoke programs, one-to-one engagements with industry, something that we've started doing more and more recently. And I'm going to tell you why I think that's important in the direction that training needs to go later in this talk. Online, we have our flagship training program, Additive Manufacturing for Innovative Design and Production. You may notice we at MIT like very long names, but we just call this AMX to keep it short. And that's the course that, as when I say I've taught over 10,000 professionals in additive, like 9,000 of them or more come from the online training course. We also have another program called MIT Horizon, which isn't really a course per se, but more a resource that you can access. So what does our sort of journey look like? I mentioned there's 10 years here, and we can start in 2015 with our first training course for MIT students and go all the way to 2025, right? We haven't gotten there yet, but the future for us looks like focusing on industry particular training programs, application-specific training programs, and functional role-specific training programs. And I'm going to tell you why I think that's important and paint a picture for you of what I see as the future of workforce training and additive. But to do that, I want to make a few arguments based on where I came from. And so the title of this talk is Lessons Learned. I have 3 lessons for you. The first is that I think that additive training needs to progress from focusing strictly on design and beginning to focus on operations as well. And I'm saying it should include operations. Design is very important, but I think operations is also important and something that's very frequently overlooked in the training space. I'm going to try to make these arguments, right? This talk is called Lessons Learned. It's my perspective. So I'm going to try to make these arguments. I don't have like great data, but I want to sort of tell a story and use some visualizations to help do that. So when I say we should move from design to operations, I think we can start by looking at something simple like an organization chart. Obviously, this is not a full organization chart, but I think this is a good way for us to think about how does 3D printing training typically take place. And training typically tries to ask and answer 3 questions. For engineers, the question is, can I print this? Can the process form the material that I want it to? Can the process meet my functional requirements for my application? For decision makers, it's should I print it? And for a very long time, if you talk to folks in the education space, they would say that we need to move from can I print it to should I print it? I think we have that now. And then for the actual machine operators, right, how do I print it? And so this is what I would call traditional AM training, and that's offered by folks like ourselves at MIT, but also on the how do I do it side, often by the machine vendor themselves. You buy a machine, they come and they train you how to use it. Now, I don't think that's good enough, but I think it stems from where additive exists and where it has existed as an industry. So if we take a view of additive, where it fits across the product lifecycle, right, traditionally additive has existed at the extremes of the product lifecycle. The unit economics just make more sense. Additive per part costs are typically more expensive when we talk about very high production volumes, but early on in the product lifecycle for prototyping or for spare parts, those unit economics make more sense. And so for a very long time, the industry said, how do we get to production additive? And the way that we do that is we do that through design excellence, by designing parts and products that only can be made by additive and are so good that they justify an increased cost when I choose printing versus a conventional forming process. But when we actually say now that we're actually in a time of production, right? Not for every process, not for every industry, but certainly there are many, many more production use cases of additive. We need to now ask the question of, okay, we're starting to produce parts at scale. What does that imply for training and workforce development? And the argument that I would make is if we go back to our org chart, right, this is not enough. We now need to think about all the other roles within an organization that need to be trained in additive. And the fact is, you might think like HR, accounting, so on, this is not so important. Additive is fundamentally technology. But I would argue, no, there are many more questions and many important questions when you start to broaden your perspective, right? If we look at the supply chain, we might say, how do I think about a make versus buy decision in additive? If I want to buy printed parts, how do I qualify my supplier? How do I manage risk? And to my knowledge, I could be wrong. I don't know every training course in the world. I don't think there's any one additive training course that focuses on supply chain professionals. We can say the same things about even the topic of this talk, skills and talent. What kind of competencies do folks in additive need? How do I deliver those competencies? What kind of curriculum should I develop? So on and so forth. And when we have that broad organization-wide view, and we think about additive as a real mature production technology, which you can debate me if that's the case or not, but certainly we need to broaden our horizon in how we teach. So that's the first lesson. The second lesson that I'd say is, again, about getting more specific, starting to think about what production additive means, and I would argue that general training is not particularly useful. And you might point at me, if you're familiar with our courses, and say, Hayden, MIT's courses are general. And I'll say, yeah, I know, for now. And the thing is that I feel like the training needs to move towards application and industry-specific focus areas. And again, I want to make that argument from a general perspective, right? So imagine for a moment you're new to the technology, and you know your parts, your products very well. You think additive could be a great fit for us. Maybe we're like a low volume, high mix manufacturer, and we make metal parts. Okay, so imagine that's the company that you are, and you come to a trade show like Formnext, and you say, okay, I'm gonna 3D print in metal. What process am I going to choose? Well, you have a lot of options. And this is really confusing. And so if you have general training that tries to boil the ocean and tries to teach all of this stuff to everyone, right, the fact is it's become very, very hard to make an impact. People get confused, they get lost, they start chasing particular technologies, and they don't know what's real. So I don't think that teaching at this broad view makes a ton of sense. I think we need to get more focused. We need to meet the customer, the manufacturer where they are, understand what they're trying to make, how they can make it, and the role of the educator is to help navigate them through this massive wheel of process technologies, not to just hand them the wheel and say, you figure it out yourself. And you could make the same argument. Again, these are generic graphics. I just took them, first one from Ampower, this from a research paper, right? But let's say you figured out, okay, I can do powder bed fusion, I can do binder jetting for my parts. How do I down select? How do I identify the right process, the right machine? There might be multiple steps. Those steps involve cost calculation. Those steps involved design engineering work, design for additive manufacturing, right? There's time, there's resources, there's dollars spent, or euros spent in sort of figuring this problem out. And on the left-hand side of this graphic, I added some things because there are many commercial tools available, consultants, commercial resources, software packages, et cetera, that can help you. But each one of those comes with a cost, and it comes with another learning curve associated with it. And sometimes the costs can be very, very high. If you want very, very sophisticated, high-fidelity software, like on the cost modeling side, right, the licenses can be really, really pretty extreme. And so, again, if I'm an educator, and I think of my job as helping you, whoever you are, right, go from where you're starting in additive to where you want to go, helping you engineer an application and actually make parts. If I want to be able to do that, I need to be able to get specific. And so that's the second lesson, is we need to start focusing on those particular applications, particular industries, meeting companies where they are, rather than providing this very generic training, which may or may not be particularly useful. I'm sorry, I spoke really fast because I thought I'd run out of time. I'm not gonna, so I'll slow down just a little bit. And then the third lesson, this one is a little bit looser because this one is just straight up my experience, but the third one is sort of a cry for help for decision makers, and to say, please consider, if you're thinking about sending your employees through additive training, please consider the format of that training as the most important thing to the impact that you expect to receive. Because some folks take a training and they take it from us, and they say, MIT is really good. MIT, best university in the world, at least for engineering. Surely it's going to be good training. And then they send folks to MIT for like 4 hours, and they don't learn very much, and they come back and they say, what the heck? We didn't get much out of this. And in reality, right, again, I don't have great graphics here, but I just want to sort of present what we call like the time paradox, is that in our online course, in our public-facing programs, the online course is 12 weeks long. That's 3 months. That's a lot of time. So about half the folks that take that course, based on our exit survey data, say that's too much material. The paradox is that more than half say, yeah, but I want more. They want more in specific focus areas. They want more in cost accounting for additive. They want more in particular process technologies. And so I think there's some nuance there, and I'll explain how I think we can try to kind of solve this paradox by giving more content, but doing it in a way which is more focused and allowing folks to have, let's say, a shorter and more impactful training experience. In our private programs, again, this is where the call for help comes from, is that it's very, very hard for me to convince a decision maker that they should send 20 of their employees to MIT for more than a week. And even a week is very difficult. Most folks say, 2-3 days, that's the most that we can give up. Now, realistically, how much can you learn in 3 days at MIT? And the answer is honestly not that much, right? If we want to get into application engineering type topics, and ideally we do, we want to work with a customer, we want to look at their parts, print those parts, iterate, define a post-processing strategy, and so on, right? 3 days, we may not even get to a single print.
because the first day we'll spend looking at the file, distilling that part down into its fundamental requirements. In almost all cases, the first part we'll look at is something designed for casting or machining, not designed for additive, so we'll want to make a design modification. We'll also then need to evaluate what process can we use to print it, and we might need to make further design modifications based on that manufacturing process, as well as the post-processing strategy, especially if we want to machine a metal part after we 3D print it. And then on the third day, we might get to build preparation. So if I spend 3 days at MIT, I might print a part at the last day. If I spend a week at MIT, I might print I might get 2 part cycles. If the part is a short run time, I can print it overnight on the 3rd day, pick it up on the 4th, and run another job on the 4th day. So for the folks, the industry users, the folks who have engaged with additive, who are operators of the technology, right? If I told you you had 5 days only to go from a part that was designed for casting to a part that was designed and is possible to 3D print at scale, right? Would you tell me that's a reasonable time frame? I think most of you would say I'm crazy. And yet often it's the case that when we talk to decision makers, they say, I only want short training, I can't free up resources. Well, I promise anyone in the audience, anyone watching, I think it's like only my fiance, hello, but if anyone else is watching, then let me just say, you're not gonna get much out of that, and you'll probably spend more money in failed prints and wasted material over the long run than you would if you had sent folks to a training course for 2 weeks or 3 weeks, rather than just saying, a week or 3 days is the most that I can do. So what principles can we derive from these 3 lessons? How should we design training programs in the future? And I didn't do this on purpose, but I have 3 M words for you. The 4th is MIT. But I think there's sort of 3 principles that we can look to in the future. So the first is that I think courses ought to be modular. And by modular, I mean highly focused content, which is technically rich, but is focused on particular subject areas like cost accounting for laser powder bed fusion, right? Or processing TIE 6.4 with XYZ technology. This is the way that we can sort of solve this time paradox where folks can say, yeah, I want more content, I can get more in the specific area of interest, but I don't have to spend as much time globally because I'm not going through materials that aren't that relevant to me. I also think that content should be matrixed, and by matrixed I mean we need to map modules not just to the actual subject area, but we need to map those to industries, and in particular map those to functional roles within an organization. And then last, I think multimodality is very important, right? Most of our students are online students. And online is great in a sense. Online is very scalable. It's very low cost. It's easy to teach certain things online. Right? Additive is very digital technology, so generative design or build preparation are things that I can sort of teach in an online environment. But again, anyone who has run a 3D printer for a significant amount of time realizes that the best learning in additive often comes from the pain of figuring out the process and making mistakes. And if you don't get hands-on training, you never have the opportunity to experience that pain, to make those mistakes and realize how to do things better in the future. And so I think that as we start to map competencies, think about how additive needs to be translated to skills across the organization, right? We want to think not about who can take online training and be successful with that, but also make sure that we have opportunities for folks that need to go further with the technology to go further with the technology. And last but not least, I'll say that I think there needs to be greater connectivity, at least in the US, between training providers. And here, I'll give a shout out to Europe. I think Europe's much further along than we are in the United States on this front. But we need some standards. We need to come together and define what does an additive manufacturing LPBF process engineer need to know. And align on that so that it's not as confusing for the end customer, for the person being trained, so that they can make better decisions about what training program makes sense. I think it's also important for the workforce to be able to empower folks with professional certifications that are nationally or internationally recognized. And at the moment in the US, we don't quite have that. So the way folks look at training is they just say which name is better and which syllabus looks better based on what I want. And I think we can make more of an impact there. Now let me give you an example of how we could implement these types of principles in practice. This is just an exemplary program structure. It is not the real one for our future coursework, but hopefully it gives a sense of what I mean by modular and matrixed, right? Is that we have many different focus areas. Those focus areas are more tight, are more compact. These might be 1-week modules, 2-week modules, no longer. But then we can map those modules to different job functions within the organization, and we can start to build customized programs very, very easily by taking these modules and stacking them up like Lego bricks until we have a finished program at the very end. Now, that's more or less all I have to say about training, but I want to end with kind of something I think is insightful when we think about the journey of additive, where it is today and where it goes in the future. And I want to draw a parallel between 3D printing and CNC machining. And so if we look at the CNC machine, right? The CNC machine was invented more or less in the 1950s. About 1953, this is when this photo is from. There's one CNC mill in the entire world. It was actually NC mill at that time. One NC mill in the entire world. And CNC back in the day is a lot like additive in that you needed very customized skill sets and very customized machinery to make it work, right? Originally, only like 3M, the 3M Corporation could make the tapes that gave the machine instructions, and only GE could punch those tapes out and encode them with a toolpath. So back in the day in 1953, there was one NC mill. It was really, really hard to operate. And if we fast forward 45 years in the future to 1999, there was only 20 to 40% adoption within manufacturing of CAD, computer-aided engineering, and CNC. So it took a very, very long time for CNC to penetrate, and the argument that this paper makes in sort of the middle image that you see is that it was the diffusion of CAM, computer-aided machining, and CAE, computer-aided engineering, such that when, actually CAD as well, that when there was enough digital infrastructure to make CNC easier to use, then folks started to use CNC machines much more often. And now if we look at today, right, this says 2023, but you know, it's 2024. There's more than 600,000 CNC machines in the world. We have many companies at the show like Meltio, DMG Mori, and others who have very advanced and sophisticated equipment, combining additive and subtractive manufacturing processes, but it took a really, really long time to get there. And so I think the job of educators is to try to play the role that CAD CAE did for CNC machining, and play that role in trying to make things easy and facilitate the conversion to additive or the adoption of additive for certain parts at production scale. So with that, that's all I have to say. If you want to send me an email, you want to talk about anything, please feel free to do so. If you are interested in the course, I'm legally obligated by my marketing department to put the link up there, but for sure we can chat about it if you're interested. Thank you so much for your attention. Appreciate y'all being here.
A round of applause for Hayden. So Hayden, thank you very much. Very, very fast forward your presentation, but full packed with infos. Great. I just checked the live stream, LinkedIn live stream. There were no comments or questions. If you allow me, we have some seconds left here on stage together. Sure. If you allow me one question, we have today's a day skills and talents, and in Hall 12 there are some activities for young students, for people who want to start into the business. What would your advice be when these young people are looking for a company? Which are the questions they should ask, or the aspects they should focus on when looking at the right company to choose?
That's an interesting one. I think ultimately it depends on what you want to do, how you envision the way I always look at this is like, what career do you want to have shouldn't be what job title or what company do you want to work for. It's what do you want to do on a day-to-day basis. And I was having a really interesting chat with an engineer yesterday, like the head of design engineering, who said he loved additive. He got involved in additive because it involved a little bit of everything. It wasn't just component design, it wasn't just quality or material science, but it involved all of those pieces, and for him that was very exciting. So my suggestion is don't focus so much on the company or on the title, but focus on what daily work looks like, and if that sounds something that's exciting to you, you'll probably have a good time.
Maybe the products can help. When you look at the products the company is producing, that could be a part of the equation. Or could it be helpful to look at the industry sector? Is it differently to work or to start work in a company who is producing parts for automotive compared to another in medicine? I think it's so.
Well, there should be different amounts of stress involved for sure. I mean, like high volume production with tight margins and so on, you can expect to get yelled at once or twice. But, I think that's important. It's like if you find work meaningful, particularly meaningful, you feel like you're making an impact in the world, for sure that can help. But ultimately, I still just think it's about figuring out, is my day job going to really, there's an expression, right? If you love what you do, you never actually work a day in your life. And I think that obviously we all hope that to be the case. We're not always so lucky. Maybe you are, but I think that's where everyone should aspire to be.
Maybe that is a very good advice for all of us. Thank you very much, Hayden, for being with us, for sharing your insight. And if you want to have contact to Hayden, he's still a bit around. Where can I find you at the exhibition?
I'll hang out here because I'm on a panel in a little bit, so you can come and stop by.
Make sure to make contact with him or use our LinkedIn live stream, and then you can ask your question and you will check if there are certain questions for you.
Sounds good. Thank you so much.
Thank you very much, Hayden. And a round of applause for Hayden. Yeah, I'm looking at the next part. We have a next highlight block, and we will see you again in some minutes.
The ILAK and ISW institutes created the Marinaressa Coral Tree, a lightweight concrete structure showcased at the Venice Architecture Biennale. Using 3D printing for recyclable, water-soluble sand formwork, it saves 60% material use with no waste, supporting sustainable construction and decarbonization. Quorum Orthopedics developed the Quattro, a revolutionary prosthetic socket that offers enhanced comfort and adjustability. Using MJF printing, it features customizable volume and modular structure, making it easy to fit even with swollen limbs. It's a sustainable solution transforming prosthetics. Siemens, with the 3D Process Consortium, is transforming the chemical industry using AM. By creating optimized reactors with complex geometries, Siemens reduces energy use and material waste. This approach accelerates development and makes chemical production more sustainable and efficient. AM Systems innovates with its multi-laser patterning module, combining multiple laser beams for high resolution and productivity. This scalable module delivers precise targeting at 20-micron spots, paving the way for the next generation of high-quality, high-volume industrial 3D printing technology. Fraunhofer IGCV developed a patent-pending powder bed fusion process that produces battery cell housings from aluminum, copper, and ceramic in a single step. It simplifies production, offering design flexibility and faster prototyping, which accelerates the development of advanced battery technologies. Toolcraft created a dry ice blasting system to remove support structures from metallic 3D printed parts. This semi-automated solution improves production efficiency, quality, and ergonomics. It reduces cycle times by 15 minutes per part and streamlines production. Additionally, it enhances the work environment.
Welcome back to our next session, Skills and Talents, here at Formnext TV, at Formnext 2024. Yeah, companies who want to grow their business, they need qualified personnel, and it's not easy to find one. It wasn't easy, and it will not be better with demographic change. I think we will face a lack of skilled workforce in future. An overview about the demand, the salaries and motivations of these talents we have on stage right now, and I will give the room to Nick Pierce. Nick Pierce is Managing Director of Alexander Daniels Global, and his presentation will show us detail the additive manufacturing talent market.
Thank you.
The stage is yours.
Thank you. So just to introduce myself, I'm Nick Pierce. I'm the founder and managing director of Alexander Daniels Global. I've been in additive manufacturing now for 11 years. Makes me feel old to say I came to the first Formnext in 2015. So this is my 9th Formnext, would you believe? So yeah, today's presentation, I'm going to talk a little bit about the additive manufacturing talent landscape, and you lucky people who are here today are going to get the first look at key data and insights from our global additive manufacturing salary survey, which is now in its 9th year. So we'll look at the demand for talent, we'll look at salaries, a little bit about diversity, and what's really motivating candidates who are looking to change jobs. Firstly, just a quick introduction to who Alexander Daniels Global are. We're a recruitment company specializing in digital manufacturing. Additive manufacturing is really the core of our business, and the business was founded on a belief that additive manufacturing will change people's lives. My story, I got into additive manufacturing because I saw the transformative capability of the technology in medical applications, and that inspired me to found this company to basically enable the revolution that I was seeing in additive manufacturing through talent. And so with our business, we work globally with offices in the UK, Germany, and the US, and we help this industry by finding great talent. So let's have a look at the workforce, and let's first start by looking at what's been happening in the landscape for this industry in terms of people changing jobs. So what we can see in the slide here is that, as you might expect, during the COVID years in 2020, we saw very little movement in this industry. Obviously, post-COVID, we had what's known as the Great Resignation, if people are aware of that. And, we can sort of see that, across North America and EMEA, we had really high volumes of people changing jobs. And that continued still into sort of 2022. And we're starting to sort of see that dropping right off then in 2023 as market conditions within the additive manufacturing industry started to affect the demand for talent. And so there were fewer opportunities and fewer people who were then, changing jobs. Now, I think what we see now in this rebound in 2024 is ultimately driven by a little bit of uncertainty. The industry is going through challenging times, and that uncertainty, as well as, well-publicized layoffs, has seen a number of the workforce having to change jobs as a result. What we can also see now in terms of salaries is how the correlation between candidates who are changing jobs impacts then what's going on with salaries in the industry. As you might have expected, in 2020, actually salaries were going down. People were not being paid as much as they were in years which were economically better. But as we saw in the previous graph, those salaries rebounded significantly in 2021 as the demand for talent really accelerated in the post-COVID years, and continued into sort of 2022. I think what's notable here is that, in particular, the APAC region, which is the grey line on the slide, recovered slower from COVID. So we have a slightly different curvature there, whereas, certainly EMEA and the US rebounded very quickly with very, very high demand for talent. What we're starting to see now in terms of the salaries, for example, in the latest data that we've collected for 2024, is what I would call more normalization of salaries. Salary growth that is around or slightly above inflation levels. I think what we're seeing is the economic headwinds in China are really starting to impact salaries in Asia. And later we'll look at more specifically the disciplines and how they're impacted, because in some instances we are still seeing growth in salaries. In other instances, and in particular in APAC, we don't see much growth at all. So what I want to talk about now is the growth of the workforce in additive manufacturing. So, taking this slide in isolation, what we sort of see here is that the overall growth of the workforce for this previous year is around 8%. If I look back to previous years, so, going back to sort of 2022, we were sort of seeing growth rates of around 22%. 2023, we were still seeing growth rates of around 18%. But what we're starting to see now is a general trend that the growth rate of talent entering the additive manufacturing industry is slowing down. Now that creates a challenge for the industry. Okay, admittedly right now the industry isn't growing in the same way as it has been in previous years, but the fact that we're seeing this slowing in growth rates, and we'll look at it a little bit later, we'll start to see where that's going to create some impact in the industry around certain skills and certain roles where actually we do still need growth. We do still need to inspire new people to enter the industry. And I think the challenge that an industry is facing now with slowing of the growth of the workforce is that actually when the industry does pick up, and inevitably it will, because it always does from a cyclical standpoint, we might not have the talent we need to really feel the benefits of what this technology is really capable of. This slide tells us a little bit about the sort of talent demographics. So when I first got into the industry sort of 10, 11 years ago, the real gap in experience that organizations need were that sort of 2 to 5 year engineer that, understood the technology, either from a design standpoint, from a process standpoint, from an manufacturing, engineering standpoint, and that was a huge gap that we sort of saw. Well, now what we can sort of see here is that, those people with, for example, 10 plus years experience in the industry now accounts for, over 28% of the industry in our most recent survey. So we see now what I would call a maturing workforce. So what this means is that actually we have now got people with 2 to 5 years experience, 5 to 10 years experience, and indeed, vastly experienced 10 years plus, who have knowledge around the technology and have that experience built up over years to really now take the technology forward. And I think this is really important in helping the industry to identify new applications and ultimately to grow. Where the problem arises, for me, and what I see in this data in particular is, let's look at those candidates, and this sort of speaks to what Hayden was talking about a minute ago. How do we get those candidates in that have no experience? Because actually that's where we see a lot of demand. In particular, a lot of the clients that we're talking to now who are trying to adopt additive manufacturing technology need entry-level people. They need people to run machines. And actually what this chart shows is that at that level, people with no experience, people even with 0 to 2 years experience, so just basic understanding of either the machine, the process, design, applications, they aren't there. And this is where the gap is really starting to arise in the workforce. And, you know, again, coming back to the previous slide, the slowdown in the growth of the workforce is not happening at the 2 to 5 year, 5 to 10 year and 10 year plus levels. The slowdown in the growth of the workforce is happening at the very spot where we need it most, which is at this early entry level. And so this is a major challenge that I think the industry is going to face in the coming years, where we actually have machines in organizations that are not being used. And they're not being used because they don't have the people to run them, to use them. And so here we have an untapped resource that could really help this industry to grow and accelerate. And the barrier to that is this entry level. And in fact, you know, I saw, I think last week, as a precursor to Formnext, an investment strategies talk that was sort of hosted by AM Strategies. And Brigitte, who's the CEO of Materialize, said that when she talks to customers, there's three main challenges that her customers face in leveraging this technology, and one of those was talent. You know, and still, this remains an issue. Now, I gave a presentation, not on this stage, but at Formnext back in 2016, where I was talking about the fact that we've got this 30, 35%, 40% CAGR for additive manufacturing, and talent was going to be an issue. And I'm now stood on the stage in front of people again, some, you know, sort of 9 years on, and we're still facing the same problem. So the question that I pose to the industry, to educators, is what are we doing about it? What are we going to do about it? Because ultimately we're 9 years on and we haven't moved far enough to really, really leverage the fantastic opportunity that additive manufacturing presents for industry. So I'm going to get into the detail now and talk a little bit about, okay, where is the demand for talent? So the area that is most in demand, according to our survey, is R&D. So again, this points to the fact that adoption of this technology is there, but you know, those companies, 50% of the companies that responded to our survey said that they will be hiring in R&D in the next 12 months, followed surprisingly by sales, but we'll drill into that and sort of see, okay, exactly what roles are we looking for. I love this. This chart. I think it's probably visually very stunning. Maybe difficult to kind of read and sort of see, well, what is it actually telling us? But what this does is it breaks down within each discipline what the most in-demand roles are across the different sectors. So, of that sort of 50% of companies that are hiring in R&D, what I can tell you is that the two most in-demand roles there are process engineers and additive manufacturing engineers. So what they're telling us is they need people who understand the manufacturing process, can optimize the process for production, and they need people who understand demand, who can help them develop products that can leverage this amazing technology. We saw in the previous graph, sales, you know, is relatively high, but the type of sales profile that people are looking for has changed. So we're not looking for the 5 to 10 year plus experienced sales guy. In this market, which is challenging, what are being hired are entry-level salespeople, business development reps, inside salespeople, cold callers. You know, we've got to grow this industry. We've got to present this technology to new organizations. And so that's where the growth is from a sort of sales perspective. I think this is, say a picture paints 1,000 words. You know, what this is telling us is a little bit about what's happening in the market at the moment. And I know I've been sort of saying there's not enough talent. You might look at this and say, well, 120 candidates for every job. There's plenty of talent there. Really, what this shows is actually, yes, the AM jobs market by a factor of 6 in the last year has gone down. So there are 6 times fewer jobs this year than there were last year. And that's why this is quite a sort of stark statistic to look at. But as I sort of highlighted, there are gaps that aren't being met. So while there are 120 people for every job, they're not at the levels or with the experience that is required by companies that are hiring. So that's why I think this is a little bit misleading. So let's have a look at what this means for salaries. Actually, you know, for the first time, we've seen relatively low growth in salaries. The part of the market, and this is a consolidated view, and we'll look a little bit what's happening in the US, in EMEA, and in APAC individually in a second. But what this is telling us is what's going on globally. Applications and consulting has seen the biggest growth in salary overall, of over 8%, and R&D and engineering 6%. So thinking back to where the demand is, salaries are still growing where the demand is. In areas like, you know, service, software, sales, we don't see salaries increasing at the levels that they have been in previous years. Looking at in isolation, North America and Canada, we can see evidently that R&D and engineering is a really, really high demand. I mean, Trump's appointment, made in America, this is good for the industry. We are going to see huge demand in this area next year for R&D and engineering talent along the lines of what I explained, process engineers, additive manufacturing engineers. In EMEA, applications and consulting. So again, those people who understand how to leverage this technology, how to maximize the value of additive manufacturing inside organizations. In APAC, interestingly, we've seen declines across almost every salary area, every discipline, with only applications and consulting holding growth rates in 2024. A big topic for the industry has always been diversity. One of the things that when I first entered the industry that I spoke about a lot with companies was the fact that, you know, the male-female split was really, really imbalanced. We've collected data for 9 years. When I first started, this ratio was around 10%. So actually, I think it's quite a positive sentiment now that we see a better balance of gender diversity in the industry. And this data is taken both from our salary survey and LinkedIn Talent Insights, which is a tool that we also have access to. And, you know, I think the fact that we're getting close now to sort of 24-25% in terms of the gender diversity speaks volumes for some of the programs that companies like EOS, HP have really focused on to drive diversity in the workforce. So when we do the survey every year, we ask candidates, you know, how likely are they to change jobs next year? One of the things that's really striking about this year is that the uncertainty that exists within the industry has seen a shift towards a greater proportion of people saying they are extremely unlikely to change jobs. So I think it's a 30+% increase in the people who are saying now that they're extremely unlikely to change jobs within the next 12 months. I'm trying to whistle through this so that you get all the content, so I'm going as quick as I can because my time is going down rapidly in front of me. Motivations to change jobs. When you ask someone face-to-face what motivates you, career progression, yeah. Great culture, yeah, always comes up. When we survey people, and it's anonymous, salary. You know, it's the unspoken thing, but actually it is still the number one motivator for why somebody will change jobs. Second then is career progression. Interestingly, what we see in the report this year is that actually people, we would estimate, are a little bit demotivated, and actually the only two areas that have increased are work-life balance and company culture. Those two things as motivators have increased in 2024 versus where they were in 2023. I think I'm going to get there just about on time because this is my last slide. So what does the future look like? I've talked about those areas of demand around operators and technicians. This is going to be the key to the growth of the industry. We need more entry-level talent. I think we're going to see some what I would call brain drain. as the industry is facing challenging conditions, I think some of those 10-year plus people or 5 to 10-year plus people with experience, where there are fewer opportunities for their growth in this industry, we might lose them. We're starting to see already normalization of salaries and demand for talent. 2 or 3 years ago, the proliferation of salaries was unsustainable, and I think that those times are over. And then finally, I think what we will see is a more flexible workforce. I think the rise of contract and on-demand hiring or staffing, as the industry grows, a more flexible workforce will help it overcome the sort of peaks and troughs that we might see in this industry. So yeah, that's the end of the presentation. Again, as Hayden said, marketing will kill me if I don't say this, but you can download a copy of the 2025 salary survey from our website from Monday. So, and then I'll be available for any questions. 10 seconds to go. How's that for timing?
That's a very good timing. A round of applause for Nick. But the good news is we have a little bit time left for one question. I just checked the LinkedIn stream, the live stream. There was no question there. I highlighted your presentation because, as you said, everybody's interested in salaries. That's always the same. But I would be interested in the slide you mentioned, the 120 open searching talents and one open job description. I did not really understand it. Do these 120 people are not really, fit? Are they not fit enough, or is the demand too high from the companies? What is the problem here?
So what this slide shows is it doesn't sort of take into consideration a specific job profile. So that could include sales, service, marketing, R&D. And basically, it just shows the total number of jobs being advertised in additive manufacturing compared against the total number of candidates looking for jobs. It takes no consideration into where those jobs are based or what those jobs are.
Do you have a personal feeling because you're talking to a lot of guys?
Yes. I mean, yeah, there are certainly levels within this industry where, if, for example, you posted I don't know, say like a sales director or something like that, you will get 120 applications for that role, and the relevance of those applications will be probably not that high. If you were posting for, say, a process engineer with specific experience of laser powder bed fusion, you'd probably get not as many responses and even fewer that were relevant.
Okay, I see. But that could be a learning from that that the companies should invest more in education for so they can get in some lower qualified personnel and start. You watched the presentation of Hayden?
Yeah.
Just the previous one, and that was a learning there as well, that you should invest as a company, because they don't want to send the people for 1 week to the trainings.
Yeah.
So the message should be they should build up their own training for their own personnel.
Yeah, I'm conscious we're short of time, obviously, but to answer that, my personal belief is that there's a lot of theoretical training in this industry, online courses. This is not a theoretical industry, it's a practical industry. We have machines, we have materials. And so I think the gap that isn't being bridged by the educators fully yet, it's starting to at a university level, but not by the training providers, is practical, hands-on learning. You've got to work with machines, and that's not being addressed, in my opinion.
Okay, thank you very much, Nick. An applause for him.
Thank you.
I wish you great success, and stay around here for making contact with one or the other who want to have it. Yeah, after a short highlight break, we will be back in a second. Sven will be moderating our next panel session topic, again, skills and talents. See you then.
3D Printing Nerd is a YouTube show hosted by Joel Tellen, exploring the world of additive manufacturing in depth. With expert interviews, tutorials, and demos, it makes complex 3D printing technology accessible and fun. It educates a global audience about the future of manufacturing. Stanley Tong has been pivotal in driving additive manufacturing adoption at a major vehicle manufacturer. His tailored training programs and expert network have made 3D printing accessible to thousands. This has ensured its integration across all levels and boosted AM adoption within the organization. The University of Stuttgart, in collaboration with the University Clinic Freiburg, developed innovative dental bone grafts for treating bone defects. Using ceramic-filled resins and precision implants optimized for DLP stereolithography, they advance bone regeneration, expanding additive manufacturing's role in dental care. AM Systems innovates with its multi-laser patterning module, combining multiple laser beams for high resolution and productivity. This scalable module delivers precise targeting at 20-micron spots, paving the way for the next generation of high-quality, high-volume industrial 3D printing technology. Fraunhofer IGCV developed a patent-pending powder bed fusion process that produces battery cell housings from aluminum, copper, and ceramic in a single step. It simplifies production, offering design flexibility and faster prototyping, which accelerates the development of advanced battery technologies. Toolcraft created a dry ice blasting system to remove support structures from metallic 3D printed parts. This semi-automated solution improves production efficiency, quality, and ergonomics. It reduces cycle times by 15 minutes per part and streamlines production. Additionally, it enhances the work environment.
Artists that specialize in 3D. Yes, it's possible here at Suto's booth. Let's have a look.
We are artists that are using 3D as a tool since a few years, and we love it. We fell in love and we deep dived into it.
I wonder how they choose their motors when designing for the 3D printer.
Since we are artists, we always create concepts for series, and in combination with the 3D printing, it's always for us important that we have like a message that we transport through the art.
I wonder if there are any restrictions in terms of shape and size for 3D printing in art. Or maybe it's only in my brain.
No, not really, and we always try to get a little further there, so we have our own print workshop with SLA printers, FDM printers, we have upcycled filament makers and shredders, so we can create our own filament, and we also do cooperations with other concerns here from the fair, for example Builder Extreme or Photocentric, where we create big showpieces and make cooperations and cross-communication projects.
I wonder if 3D printing is the way to enlightenment.
Hello, ladies and gentlemen, and welcome back here on the industry stage at the Formnext 2024. I'm super excited because we are starting our first panel on day number 3, and it will be very special, I can promise already. We are focusing on a topic here in this panel that is something that affects all of us, but not only in our industry, but also in all industry. We are talking about skills and talents today. this year, so many things are different at Formnext, and we want to do that on Career Day as well. So instead of falling into the usual lamentations, let me point that out, yeah, our aim is to explore a new and innovative approach to inspire people about additive manufacturing. And you know, I'm not at all an expert in this, so we gathered together an excellent lineup of experts. So let me introduce our guests in our panel discussion. To my left, there is Hayden. We heard him already in a speech today. Hayden Kinlan, you're a Senior Program Manager, Massachusetts Institute of Technology, or the MIT. Great to have you here, Hayden.
Thank you.
Then, next, Dr. Irene Skibinski. You are Project Manager at VDMA. We're talking a little bit about that more later. Thank you so much for being here, Irene, again, in this important topic. Then we have Vadi Yaret. Is that correct, Vadi?
That's true, yeah.
Can I say it that way? You are a researcher at the Institute for Manufacturing Technologies of Ceramic Components and Composites at the University of Stuttgart. And then, I'm happy to have you here, guys. So we have Dave Intoman. He's executive producer at 3D Printing Nerd, and many, many more, that's for sure. And last but not least, and you know this guy, because if you have watched his show on Monday, you should have seen him. I've seen him only 2 minutes. That's a little bit the pity.
2 minutes out of 3.5 hours? Come on.
2 minutes were already exciting, so a big applause for Joel Delling as well. So he's the host of 3D Printing Nerd, and I think all of you know this already. So as I said in the very beginning, I want to do something different today, and I hope you are with me. So I want to create with all of you a plan how we can spark talents interested in additive manufacturing, or how we spark talents interest in additive manufacturing and draw them into our secret community, let's put it that way, and they will never want to leave. That's the plan, okay? So I want to start a virtual collaboration with all of you, and we can build upon in the future. That's a little bit the target for this panel discussion. And to kick it off, I said, let's do the same question for all of you with a little bit of variation. So Irene, we start with you. You are working at VDMA, and probably you can point out how can you contribute to the topic of talent acquisition and fostering enthusiasm?
So in the VDMA in general, we have a lot of programs on talents and skills. So what we are doing now is we hop on those existing programs with additive manufacturing topics. And I think we're in a quite easy position because AM is really attractive for a lot of young people. So normally, it's really easy to get the kids and the students on board.
Okay.
And then they with their enthusiasm, they also bring their knowledge into the companies where they go to.
So we come later to the point how your network partner or your members see the current situation, but let's first go over to Vahid. So you combine interactive lessons, that's what we discussed in our briefing session, with a YouTube presence. I watched it, super interesting, very well produced in my opinion, super nice. So what would be your contribution? Would it be more on the media side or more in your interactive lessons? What are you actually doing to attract talents?
I figured that you can inspire people through videos. Anyone who's on YouTube knows that attention rates higher than 10% are almost impossible. They're very difficult. So most people that watch up to 10% of your video. And to inspire someone is good, but to make them into a skillful talent that would be committed to work every day in additive manufacturing is something else.
Yeah.
And I figured that making a YouTube video is great as a starter, but committing to it through training, through working with students, like my students there, you can raise your hand, say aye, on a day-to-day basis, and inspiring them through continued vision and having people to be, inspiring people or teaching people how to be patient, I think is what's needed. And this comes with time, with training. That's why I'm focused there these days.
Very good. I mean, Joel, you invested quite some time in the industry and building up your channel in order to inspire people.
A little bit here and there, yeah.
A little bit. So I just told David in our upfront conversation, I looked into your videos, and you know what I like about that? It's so easy to follow. It's not that someone who's, and because I'm not an additive expert at all, yeah, but if I follow your videos, I'm totally in, and you catch me right away, and it's more about I learned something new without being an expert. That might be your contribution, right?
You know, that's a really interesting way of putting it, and a lot of what we try to do on 3D Printing Nerd is rather than instruct and teach, we want people to learn along with us. I have a passion for this, and we have a skill set that allows us to formulate certain topics in a way where instead of me saying, here's what you need to do to be successful, I can say, I'm learning how to do this. To be successful, learn along with me. And when talking with building skills, I think being able to bring someone along for the ride rather than telling them what to do brings more people in.
For sure, for sure. David, we take our point that we discussed at the last one because it rounded up, in my opinion. So Hayden, if I hear MIT, honestly, I was thinking about going to MIT to follow one of the programs. But for a beginner, it sounds challenging because MIT is such a big, intimidating name. Let's put it that way. Don't get me wrong. Yeah? It's rather positive feedback. Yeah. So. I'm sure you have your ways of attracting new students, but not only students, also skills. So what is your contribution? What are your initiatives, and what are you currently doing in that topic?
Well, we're doing a lot mainly on the professional side. We have online programs, in-person programs, and so on. And being intimidated is feedback we get very often.
Yeah.
But it's a good point that courses need to be accessible to beginners, and so we've come up with some sort of tips and tricks. We select very particular software, have glossaries of information and so on to try to make the material accessible.
Yeah, and I just observed a little bit your speech, and you were talking about this 12 weeks program, which is perceived too long. So are there shorter ones that, let's say, one that has watched a video of Joel says, okay, I want to step into that industry and get, let's say, first overview. Would that be available at MIT?
Online in the future, that's the direction that we're moving towards. Shorter, bite-sized modules, things that are more accessible. In person, definitely. We have a 5-day course that we run every summer.
Okay.
And we've had high school students come to that, as well as folks who are at the end of their career.
Okay, great to see that. So, David, we discussed one thing, and I think this is, let's say, the common ground, the basis we should start with. What do we need to do in order to tell an attractive story? Let's put it that way.
I mean, I think when you're trying to tell a story, you have to really think about the audience you're speaking to first, and understand, and also work your way backwards. Think about, like, what is your goal, and then deconstruct that backwards and say, how do I get here? You know, like we were talking about economics earlier, it's the same thing with an ROI. Like, what's the return on the investment for the viewer and that story? Is it going to be something that they're going to connect with, and is it something that's going to perpetuate that learning and that overall, you know, place in the industry for them, and find out what they want to do? Because when you look at additive manufacturing, it's a part of all of our lives in every respect now, whether people know it or not. And it's going to filter into it even more, and then some people need to use a whole bunch of it, and some people don't. And I think it's really about understanding those and not trying to force people to get engaged in things that they don't need to. You know, and really understand that, like, you know, here's the story, here's what we're doing, and it could be a vignette, it could be small, it could be these little bite-sized pieces, but it could also be something that's a multiple series where they're learning, like you were saying, modules. Like, we create series in the show where it's multi-part series, and people learn across the way from all sorts of different stuff, from big, giant industrial to smaller, you know, machines that don't require a lot of learning, but you still want to break out those steps and let everyone feel like they have a voice. And I think the most important thing in storytelling is you never, ever talk down to your audience.
Yeah.
Never, ever do that. Meet them on their level and understand that everyone learns and engages at their own pace. And if you can respect that, I think you can tell some compelling stories.
Mm-hmm. Well, one issue we were facing when we were talking, David, was the thing that sometimes an additive, and that's a little bit the mood we had here on this year's Formnext, the story cannot be told till the end, you know what I mean? So we have a lot of industrialization going on, we see that, and we can inspire people only by technology, but sometimes people, especially in difficult times, they look for the ones where they see quick and easy success. I know that you did this survey, Irene, on the mood of the members. So is it right now in these difficult times even more complicated to attract talents because they don't see the things running through the end? That means already successful business cases compared, I don't know, to traditional industries like automotive, etc. Is that an issue?
Well, we ask our member companies every half a year, what's the most relevant topics for you? And we ask, is skills or lack of skilled workers a relevant topic for you? And 2 years ago, a quarter of our member companies said yes, and now it's reduced to 10%. So for them, there are other topics that seem to become more relevant and more important for them.
Let me show some figures more, because that would underline your point, and then you can keep on explaining that. Have a look here. That's what Nick was providing us with this slide. You can see it here as well in the preview monitor if you want. So what I think is really interesting, what you see here is that the ratio dropped or increased, the way you look at it, 120 applicants to one open position. So this is a difficult situation. So as you said, probably it's no longer an issue at all, isn't it?
It seems to be less relevant for our members. I think still it's still important to improve the quality of education. It can be further education, apprenticeship, and I think we still have to work on getting really good skilled workers.
Yeah.
And also we know that that the demographic change will not help us with solving the problem. So we have to work, and we are always there are other industries that also want to attract those talents. So additive manufacturing has an advantage because it's really attractive, but we still have to work to keep up with other industries.
But that brings me back to you, and so I said it's intimidating or to apply for MIT, even if it's a course, because you think it's super complicated. So we need on the one side we need skills. It's not only about young talents we're talking all the time. As the demographic change, I mean, we need to attract as well the over 50 people, right? I mean,
wait, did that graphic say there's less jobs in additive now?
No. There are more people that apply for a job than job offerings. So the ratio of applicant is increased heavily compared to the open. Okay. It's not less job opportunities. It's just there are more people on one job opportunity.
Sure. Okay.
Yeah, there are less job opportunities. That's what.
Yeah, there's a lot of opportunities in additive. I see tons of opportunities in companies looking for people to specialize in it, and I think there's actually a lack of people for it. I think there's so many people that want to use it, especially in the small business industry, that needs to be addressed. And there's so many companies that want to bring additive in, but they can't find people to do that. And I think that's I think that's the issue. And I think even in universities, like we work with different schools in the States and programs, and they say, they had an additive program, and then, the teacher left, or someone does, and no one knows how to use the machine. Yeah. And then sitting there, and it's like, we need to do more of this. I think there's a lot of opportunities out there in that respect.
Yeah, to exactly that point I want to come in terms of, Hayden, you are, just with the name MIT, and it's a university, you probably attract more the ones that are already educated in a certain way. And on the other side, Joel, I mean, you are attracting the whole variety of people, right? I mean, they are the makers, probably the enthusiast, the nerd, as you call yourself as well.
I hear from everybody, all the way from people in grade school who have a consumer machine and they're happy to print a little Pokemon and they show me, all the way up to seasoned veterans in C-suite level positions who have thanked me because we've brought a light to their industry. And so we've seen it all.
Because I'm totally with David, and that's what I want to ask you. I mean, you are like, they are the big industry leaders that soak all the people in, but the little companies, they don't have the resource anymore then. So I think it's a different picture depending on which size of industry you're looking at or size of companies, right, David?
I think so, but I also think that people are missing a huge section of industry, and that's like auto shops, mechanics, dentists, small businesses. They want to bring these in. Like, there's so many people out there that can, you know, the way also the machines have changed. Like, additive changes exponentially, and you have machines now where you don't need 7 Stratasys machines and 4 EOS machines in your company. You need maybe 1 or 2 to do a specific element, but then you can supplement it with all these other things because the materials are more accessible now, the machines are better, you can do so much more with it, and then now all these people can bring additive in their spaces that they haven't had before. And that's kind of what I'm seeing. And then that's, you know, people I think go, oh, it's either big additive or it's, you know, consumer kids with toys. But that's a huge misconception, because what we see on a daily basis, the people that talk to us and we go out in there, it's a mix of both. Like, we've worked with companies that move oil and sand or do the sewer systems for the city of Vancouver in Canada, and they bring in a Pantheon machine and it changes their whole business model.
Yeah.
You know, they're not bringing in a $4 million machine, they're bringing in a machine that costs under $30,000.
Which is crazy, by the way. The story is crazy at all. Yeah,
it's bonkers.
If I can just maybe say, I think when it comes to like professional training, folks who are experienced already, they've graduated from a university, it makes a lot of sense to have dedicated training, like I was saying, on specific additive modules. When it comes to formal education, especially for like in the US, we have 2-year schools, or, you know, vocational schools predominantly. I feel like there's really a sweet spot that needs to be developed, which is trying to educate the next generation of what we call technologists, folks who sit between, they're not just an operator, they don't have an engineering degree though, but they're capable of understanding, you know, first principles, diagnosing problems on the shop floor, and being able to adapt to advanced technology, if it's additive or if it's some special finishing technology, you know, whatever it may be. In the US, and I don't know about the rest of the world, we have a big problem with the manufacturing workforce.
Yeah.
And so I think we need to think about how do we empower young folks, not necessarily in one particular technology, but give them foundational skills that allow them to adapt and grow a career, regardless of what industry sector, what manufacturing process they end up working with on a daily basis.
But then comes to me the next question, right? Probably you can say that. I mean, when the students come to you, they already decided, right? Or are they still don't know where to go afterwards?
I think a student, just like any other person, are never decided.
Yeah.
They're like always open. Now there's thousands of opportunities for them everywhere in the world. What inspires them, I think, and transforms them into the talent that companies need, the skillful people, are the environment in which they learn, how much we provide, how much we support, the people they work with, how we inspire them, how friendly we are, how easygoing we are. Science has a bad reputation, unfortunately, of being complicated, sometimes boring, especially universities. So they can always choose to do something else. And they always get inspired by videos like Jules. But at the same time, what we need nowadays are people with a long attention span, to be patient enough to go every day to work, be excited and inspired internally, not just by the external factors or the profit they're getting. And to sit down and really analyze the data again and again and again to come up with these great ideas. This is what we try to.
But then I see, like, and this is what we can work here in this panel discussion. I mean, let's say I watch Joel, and I say I'm super inspired. I was maker and I tried it out a little bit, no technical background, young person, let's say 14 years old. We are not talking about like already educated in it. And that's what you said. I mean, we need to bring them into technology. So now I'm addicted, Joel. I'm with you.
I appreciate that.
Yeah, thank you. So I'm into that topic. And now I decide, okay, I want to keep on learning. And now I come from this nowadays very attractive approach of easy to consume, always inspiring, funny, as well as not only like very technical. Then I come to university and visit a course. Isn't that like?
It's fairly typical. I think one thing that I think Arena maybe mentioned apprenticeships, or someone mentioned apprenticeships, and in the US we don't do this that much, but I think to your point about how do you get people to show up every day and do the diligent but sometimes frustratingly straightforward work, if there's real impact associated with it, if you're working on an application for a company, for example, rather than just working on a research project where you're not sure where it might go, that's one way that we've found can be very effective in not just communicating what work will be like and getting folks excited about work, but also allowing them to manage that indecision that you were mentioning, right? Starting to sniff out, is this the type of job I want, or is there a different sector, a different role that's better for me?
But again, the question, I mean, let's say I'm more like, I have thousands of fancy ideas in my head, what I want to introduce. And then why it comes to the point where you have to work constantly on that, and you visit university, and then you are in the course. And I mean, I know what you do in order to inspire students, otherwise they wouldn't be here. Yeah? So does university or education needs to change also in their entertainment offering? Don't get me wrong, but this is it. I mean, if you tell a story, David, right? I mean,
well, yeah. Well, what's I can't think of his name. From Ireland, and they have the program right now that we met him yesterday. We were talking about him. Tall guy beard. They have the program.
Tall guy beard.
Yes.
Tall guy beard.
Do you know what I'm talking about?
I cannot.
If you're watching, I'm so sorry. I forgot your name. I total brain fart. But they have a master's program at a university in Ireland in additive manufacturing, working toward a PhD in that. And they have a whole lab built around all of this, and they're taking those steps to really bring people into the space and recreate real-world situations that they would be using this in, and take those people that are inspired and do that. But also the other thing too is that the technology, especially if you look around here at the event, it's gotten so much easier to use. I mean, when I first started, Joel's been in additive way longer than I have. I've been in for what, 6 years maybe? Something like that. You've been doing it longer than I have. But I mean, I was leveling with a piece of paper on my first machine and stuff like that. Now that's not even a thing, a thought. These machines work, and they do that. And I feel like the machines and the technology and everything has gotten so much better that the barrier to entry and the accessibility to the technology is far greater than it's ever been. And I think that's also something that's happening exponentially too that we have to consider.
Wait, let me jump in here, because I think we're approaching things at a much later level than should be. If we're talking about getting skills to people necessary in order to enter the job market, we need to focus on 8-year-olds. We can't expect kids and young people to adapt to an archaic learning structure, which we went through, but only because we had to, because that was the only way. But I've heard the term YouTube University way more times over the past year than I have even before that. And I think approaching the learning about additive manufacturing needs to be less gatekeeps. We can't gatekeep it within this typical learning structures. I think what we need to do, like you said, when we talk about story, is approach them at their level. We have massively successful science creators on short form content platforms disseminating physics and math and astronomical phenomenon and additive manufacturing even. And so these people, these educators, while the university structures are fantastic, I think if we can utilize the technology that even younger kids are using in order to consume, and we give them content that is not just learning, but learning in the way that they learn best, then we've kind of peppered a whole generation to come up through the school systems excited about additive manufacturing, and then being a part of clubs at school, being a part of the STEAM class, being a part of engineering principled things at the school. And then we will find people, it's because they have a preference for this now, then they go to the universities, I think, better prepared. And it's not like trying to drag kids there. We're giving them an opportunity that they're excited to have.
Yeah, it's not that giving a try, it's more like I decided on going
to
university, right?
Right.
So Hayden, how is, I totally agree with catching the 8 years, because this is the time we will need to transform probably our education until then. Yeah. So are you already doing initiatives in like a more modern learning learning environment? Is that something that is happening already?
I mean, online platforms, we're doing things in AR, VR, to try to create hands-on experiences that are, scalable online. So there's definitely a lot of room for innovation in the way that courses are delivered. But I actually want to challenge what you said a little bit and just say, I don't think necessarily that the way people want to learn is the way that they learn the best. And this is one area that I think is very important, that a lot of educators, most educators overthink, is pedagogy, is learning science, is how can I actually distill information and get that to stick with someone. And that's one area I think we all could pay more attention to, and I mean myself as well. So what we tend to see is that excitement is not the limiting factor. And we have pretty fun courses. We have like our main undergraduate course in Mech-E is called the yo-yo course, and you make 50 yo-yos, and you mold parts, you print parts, you mill parts. People come to MIT just to take that course. But I said this in my talk, and I mean this, maybe this is like a very MIT point of view, but I think people learn the best through a little bit of stress and a little bit of pain. When you make a mistake and you say, that was horrible, I never want to do that again. And so, in our courses, starting to make folks say, okay, instead of making 10 parts, now you have to make 100 parts. And you need to inspect those parts, and you need to make sure that those parts are conforming and diagnose process failures and so on. Maybe this is like too advanced for the level of discussion that we're talking about, but we see some really great results when we don't put too much stress on the students, but enough for them to really kick into gear and feel urgency. So again, maybe that's like a very MIT difficult point of view.
That's accords totally to learning psychology today, because there are the two factors. You need to transfer it into learning nuggets, defining your own speed, finding your own path, so being more like self-determined in your learning. And on the other side, at a certain point, put stress on it, because that's usually the time where people perform best. Yeah. So, but they have to learn something before. Yeah, otherwise, the stress is totally useless. So, I mean, you are in a very structured university in terms of, we are in Germany, so everything is very regulated. I don't know how is that on MIT, but I at least studied in Germany, so I know. Yeah. So, how can you transform your kind of teaching to get more to the kind of teaching that Joe mentioned?
Yes, I first want to say I totally agree with the fact that the stress generated by a project or a delivery or a failed part creates such an incredible learning experience. For everyone, I saw it in the lab. Those students are there, they can confirm. What was your question again?
No, how can you, with the very strict requirements you have, yes, like adapt to the new learning psychology, if I call it that way, don't get me wrong. Yeah.
Yes. I think learning from videos or watching someone do something is one of the oldest way of learning.
Yeah.
That's how we imitate. That's how a human being learns. But this is, I think, an incomplete model. It's great. I learn myself from YouTube sometimes. But I realized, as a YouTuber as well, that to learn something, you can first watch someone do it. I think this is what Jules does. Mm-hmm. He goes and visits experts, like you, like us, or you're an expert by now. Yeah. Film what they do, and make people watch that, learn through watching. The thing is, you can learn through watching, but I can ask you, would you learn a skill better by doing it yourself and failing through it, or watching someone do it?
I think it's a combination, basically.
Yes.
So I'm totally with you. And this is what happens to me all the time. You see something on YouTube, let's say editing a video, for example. Yeah. You say, okay, afterwards I do it myself. Then you're sitting in front of this damn machine. And even if you follow it step by step, it's not the same. Yes. So you fail. And then you say, oh, I need to probably find my own way, my own adaptation. Yes. That's a little bit it.
Yes.
So learning or watching without doing is no learning. That's what we all agree.
And this really applies to complicated topics like developing.
Yeah, exactly. You need to learn the software. You need to learn like doing a part and then taking your own experience out of it the way you do it. I'm totally with you.
Are we putting the cart before the horse? I'm sorry to interrupt if you were going to go to another question, but if we're talking about learning, we need to bring people to the learning. And so if I can, I agree with what you said about what I said, and I think perhaps we're missing something, because what we do at 3D Printing Nerd is inspire people to get motivated to do stuff. And so while we do have principles of teaching people things, the main goal is to give them that kick in the pants to go try it themselves and do it. And so there is that in-person learning element, but it's because there was something that inspired them to take that step. And so perhaps for the overarching thematic piece that we have here, it's part inspiration, and then that inspiration brings them into a learning environment.
I would like to add one more thing that we do to inspire young people is to show them career paths. So that's another topic that I'm just throwing in. So I think to show how the future of their work life might look like, or show them inspiring careers and project applications. So that's one thing that we can do, for example, to attract.
Let me come up with a vision, and I'll do this with David, okay? David, let's tell a story, okay?
Right.
So my story would be in terms of getting a business case out of what we're talking here. So we catch them with Joel, and inspire them, starting with the 8 years. Let's take this as an entry level, And very important, we tell the story in total. So David says, okay, it's not enough to just attract them. We need to show them the career path. And this must be incorporated in any of the videos at a later stage, And this is where you should work together, in my opinion. So if I explore these videos, my first initial motivation might be to try it myself and to do the next step. But then if I want to see the movie till the end, I need a happy end, right, David?
Well, sure. I mean, that's kind of the thing that's really unique about what we've created in the show is that it's not just, here's Joel with a new machine showing you how to do this. Because his experience is across the board, I mean, from software to hardware and all that stuff that led into getting into additive and that background, we'll go work with a company like Progressive Sealing, where they're out here and they're actually showing how additive is affecting the ROI of their business. And we make episodes about that and use cases to show these companies how they have had a business where they're a great use case, where they had a part that takes 8 hours to make through milling and everything that goes on with this really unique part. They brought in a machine that now takes an hour to make that part. They take the 7 hours, they reinvest that back into their company. We make an episode of the show showing that. And the episode we had before that was how to build this actual machine step by step. And it's a very complex machine. So we put all the pieces together and then, let that out there. But I think part of it is showing how it actually transforms the business. Not just you could go work in this field, but how if you get this skill set, you go through, you learn this and then you want to refine it and you go to MIT, you take these classes and you go through it. Now you get to be kind of a superhero and go work with these companies.
That's what I mean.
And go there and then get that skill and then you refine it, depend on what your expertise needs to be. But I think that there's so much availability of information that there's a lot of independent people out there. And then also you have to look at this, that there's a lot of closed ecosystems for these machines and stuff, and there's a lot of gatekeeping, but there's a whole nother world of open source that never gets talked about, and it's the core of what made all of this possible, and open source technology and the ethos behind that. I have a really cheesy saying, and I will make a t-shirt, and I say...
Don't say it.
I have to... anyway, it's goofy, but anyway, but it's no, I'm gonna say it. Open source, open hearts, right? You have to be open to the idea of it and connecting. It's cheesy, I'm cheesy, it's life. He has to deal with it all the time. But it's that aspect of connecting people to the technology and letting them feel like they're a part of it and they're a part of the story, so they feel invested in it. So they want to go on, they want to go to universities and take these paths because MIT is going to have resources that other people are not going to have. And they're going to get the chance to be there and be able to not just work with the people, but they're going to have accessibility to other stuff like that. And then you look at like how, open source technology is making it accessible for everyone and saying, hey, here is all of this. We want you all to play with this and see what you can come up with. And I think that's part of the story that needs to be told as well, too, because you're giving people multiple resources. It's not just one vertical.
Yeah, but then in the end, I mean, let me see. Let me take an example out of totally another field. Let's take Harvard and being a lawyer, for example. Yeah. So if you decide going that path, I mean, you're not thinking about how cool it would be to study in Harvard. You think about how cool it would be to wear a suit with a tie and to stand in front of people. I think that's a vision that people have. So my vision in additive, and that's totally accords with you, would be, so I'm standing right after being with you. I'm saving a patient's life because I learned how to use additive in order to put a new bone in it. You know what I mean? That would be my vision, yeah? And this is the movie we need to write.
I love that you said that. If I can pull on that thread a little bit, I do a lot of interviews for our coursework. We record the interviews, and one question I always like to ask folks is like, what was your light bulb moment? What got you excited about additive? And unless you're someone who's already been doing it for many years, the answer is never, I saw this new machine and the resolution was twice as good. Yeah. The answer is always, I saw this part, and that part transformed the way that that industry operator. Like my story is, I saw a 3D Systems marketing video, free shout out 3D Systems, where someone who had a cleft palate got reconstructive surgery enabled by additive, and at the end he takes a bite of an apple. And I think, wow, they've changed this child's life. This technology is transformative. And so I think additive can be an amazing educational tool, but maybe what gets people to get very excited is not the technology itself, but what amazing parts that we can make and how those affect their lives.
Right?
Yeah.
Yeah. Irene, you mentioned one thing. You said in the survey, one of the results is that it's not the focus thing right at the moment. Due to the overall crisis, we have other problems to solve. But this would mean for me that this is probably the time to tackle this issue even more, because this is the time you probably get until it's increasing again, and then we have the same situation. Like, I imagine, let's say it's so positive as the survey says, in 2 years we're sitting in the same panel and saying, hey, we have the ratio of 2022 again. Yeah, we have 10 persons applying for a job for one job opportunity. So isn't now the time, and it wouldn't be something that you can recommend to your members, go and take these 4 guys, including you as a project manager then, and let's build up a story and start with the 8 years and catch them? Wouldn't be the time to do so?
I agree with you, yeah. So I would also think that the ratio will change again, and so now is the time to act. So we have the right people in 5 years, right? So I mean, the studying takes 4 or 5 years. Apprenticeship in Germany is around 3 years. So, yes, we should work on it, and we should tell our members, don't forget this topic. It's still important, and we still should invest in whatever way in this topic. So we don't sit here in 3 years and say, well, we are surprised.
Surprise. Again, less people. Yeah. So no, I think my motivation, and you see, I'm quite motivated in the topic. Is, I mean, I like the creative way, and honestly, right? I mean, we had this briefing conversation, and I heard your speech. It's so great to see what even universities, how they are developing into more agile constructions. You know, I mean, you are even changing. Although this was the holy thing of having the strict student regulation and going through the exams and stuff. I think you are changing as well, making it more interactive, as White told us in the briefing call, being more focused on the customer, and the customer is a student basically, being more creative in this. So it's happening to so much, but it would be so sad to see that we missed the opportunity of this time now, where we are where the lack of people is not the main issue. Now it's the time, in my opinion, to tackle it.
Well, but I think, and you can tell me if it's true, or at MIT maybe as well, that overall the engineering students decrease, right? So
overall they do.
So universities have to change to attract the new engineers.
So why is that, Hayden?
AI and machine learning and the salaries that they can get if they graduate with a degree in computer science versus mechanical engineering, just to be transparent. That's probably the largest driver. And I think this is to your point about showing folks the career path, is that students make decisions in what they want to learn, both as a function of what they like, but also as a function of what they're going to get out of it after they finish their degree program. And so if we, I don't know, maybe we need to pay additive engineers more. They're already pretty expensive, but having tried to hire them. But in any event,
that would then agree the points that Nick was presenting before with a salary review. And I'm not too much into that point, to be honest, because of course you can be salary driven, and probably it's one of the main topics why we have a move now into the AI field. On the other side, I think if you are motivated and enthusiastic, it's always more worth than getting more salary. I don't know. Yeah. So I go with Joel to get the 8 years, of course. That would be great. So let's tell. Yeah.
I'd just like to answer Rine's question regarding this point from my perspective, from what I saw in the numbers. Sometimes the overall number of students in the mechanical engineering program could decrease, but certain fields within this program can actually increase in numbers. So some people might be more interested nowadays in additive manufacturing, and their numbers are increasing, while internal combustion engines might be decreasing, for example, because of electric cars.
Yeah.
So it's, you know, it's kind of, it's more detailed than just assuming the number of students is decreasing.
So we were talking all the time mostly about talents, okay? So we are tackling young persons, so we can skip now the 8 years. Let's go to the people over 50. Is that a target group you attract as well?
1000% yes.
Yes,
I get
you do,
lots
right?
of people from all ages, but I find that, and this is absolutely fascinating, because I find that I will get older men who have lots of hobbies and don't necessarily have social skills, and they will find that I'm going to be at a show, like a consumer show where we have lots of DIY things, and they will make their way to the show specifically to meet me and tell me how much 3D Printing Nerd has inspired them. And usually, you know, we'll get a picture, I'll put my arm around them, and sometimes they're shaking, they're so nervous, but they were so inspired. They broke the mold and went out and, well, took a picture with me and met me and told me how much I had inspired them.
Yeah.
And so I think that we're absolutely reaching 50 and over. I think we're absolutely reaching these people. And I don't know how many of those are actually, I don't know how many 50-year-olds are starting a college career, right? I don't know how many of them are starting college and looking to learn for the next 4 to 8 years.
It's a lot more than you'd think.
Is it really?
Not through the degree program track, but on our professional training courses, our learner distribution is actually the number one population are folks who are in the end stage of their career, 45 and up.
Sure.
And then number two are folks at the very entry level. It's that in between that tend to say, we're doing our work, we're just focused on that, I don't want to learn.
That's so cool.
Well, part of it too is also that a lot of technology has changed, jobs have become redundant, and so it's a re-education of the workforce, which is the most important part that I think additive is playing. And like you mentioned that earlier too, you know, in the United States, you know, manufacturing has shifted in a major way. Globally it's changed in a lot of places, but additive is a new technology for a lot of people, and we're using it to re-educate the workforce because it's supplementing careers and skills and the way we do business, the way we build our buildings, the way we handle medicine, the way we handle all sorts of stuff, food, you know, clothing, fashion, everything you see here, it's all part of this re-education and people constantly learning. And so all these resources combined together are allowing the evolution to continue.
Yeah, the only thing I see, I mean, when I see a lot of these middle-sized companies in Germany where you have really old workforce from time to time, and they're super well educated on a technical basis. But if it comes to, let's say, IT stuff or new methods like AI or even use the new software we are looking at in 3D printing, they have difficulties to do so. Because we don't want to attract only the engineers, already ready engineers, we also want to attract those who have a usual education and work as technicians for years. So are there programs at MIT, for example, to attract these people and to support them in doing the shift?
Yeah, I think that's a thing that we struggle with in our online courses is folks, maybe they won't struggle with the content, but they'll just struggle with navigating the platform, with using an online platform versus the way that they're used to working. And I think, to be honest, the best solution we found, I don't think it's a perfect solution, is just to spend more time with them, to have office hours, to build video tutorials, really just try to figure out what are the pain points and make it easy. In the long run, and this is true both for folks who are less tech savvy as well as, honestly, one population that's almost never talked about in engineering are folks with disabilities.
Yeah.
I think there are some tools that we can build, AR, VR-based tools, things like haptic CAD devices that are just sort of emerging now that might make things a little bit easier, a little bit more accessible for a very broad population, including older workers.
I'd like to add something here. Back to the numbers you showed. You showed that there is, in 2024, 129 to 1 people versus offers of jobs. So we see that the problem is not in numbers of 1,000 subscribers or million subscribers or a lot of people. It's about the skills and the talents, or the quality of the individuals.
Yeah.
And in fact, if one machine in this hall now is a breakthrough, this whole Formnext is going to be interested in it. This will be the focus, even though maybe one person worked on it or two. So the numbers are not the problem. The problem is, how do you get a skill transferred to a person that will make him or her into a real talent, a patient talent, someone who is persevering. And
maybe I can add to that, because we also asked our members how they train their people, and most of them do it on the job. And we asked them, do you think there should be more further education? And they said yes. And we asked them, but have you ever brought your people to a course? And then they said no. So there seems to be also a lack between wanting and doing, and also I think within the daily life and working, it's quite difficult to add something on top.
But that's exactly where I come back to Joel and David. So in my opinion, if you want to attract, and they are already attracted, as we heard, and you want to get them into like a professional education or on the job, wouldn't it be necessary that you work together and transfer the whole thing in terms of, we get them into, as experts, how to communicate to those guys, because they have already access to them. You know what I mean? In order to attract them to do an additional education. Because sometimes you see so many companies looking for talents and they produce their own videos without talking to, in my opinion, experts. They talk to a good marketing agency and then they do a video, and everybody like the German military, for example, where you are super inspired to get a soldier, but it's not really attracting the young people because it's so far away from reality. So wouldn't it be good to make cooperations here?
Yes, we will work with MIT. It's okay. Yes, we will do it.
No, you know what I mean.
But no, I completely agree.
But
we just did a whole series with UC Berkeley.
Yeah.
Like we did a whole thing with their microengineering lab at UC Berkeley and Virgin Galactic and 3D printing in outer space. I mean, and we were going over computed axial lithography. And we went through all the CAL options and everything like that. And that's, we have other stuff coming in the future with other universities and breaking it down. And the results of what we did, the university got a ton of attention from students that want to be engaged with it. They were able to highlight the papers that they did and got more, accessibility, more viewing. Like Taylor just sent out another thing too about like everyone now knows about the research that they're doing, and that's not just attracting talent, but it's also validating the work they do, and it's also getting them more resources to grow and do more and stuff like that. And I think it all works together because we all have the same goal here.
Yeah.
We all just want to make the world better, and this is a great tool for that.
Yeah, and there's one more thing that we do. So we also talk to teachers. So we prepare, for example, our members prepare information on additive manufacturing and education material on additive manufacturing for the teachers well, at least in Germany. And I think that's also a way to get students to be able to work on AM and
This
learn
is a
something.
hugely important point, I think, is that giving educators tools to be able to incorporate additive into the course into their
assets,
coursework,
basically,
and,
right?
and not just from machine vendors have some things, and it's clearly from like sort of a sales vertical point of view, but maybe to your point, David, about open source and opening hearts. I like the expression, regardless of what you think, Joel. Maybe there's an opportunity there to build resources for educators themselves, because the story of someone buying a printer and then it collecting dust because they left is totally common, especially at the high school level.
Yeah.
Why do you get the final words?
I wanna I thank you first for the point you brought up about connecting, and I think it's very important from the get-go, from the beginning, to show those students or kids career paths, like Arena does, so that they know what to expect. Because we don't lack people, we just lack the right people.
Yeah.
And I think this is where I would love to collaborate with you, so that you can bring some of your students to the lab and show them what we do, what we struggle with, so they have an idea of what to expect.
Yeah, very good. Thank you,
And hopefully
guys.
inspire them.
I think the five of you will definitely inspire the people, that's for sure. Thank you so much for being our guest here today on our stage for the fruitful discussion. We haven't got to the final cooperation yet, but it's a good start in my opinion, so thank you very much for your input. So ladies and gentlemen, and kids at home, you listen to that. If you're 8 years and older, please step into additive manufacturing. No, thank you very much for listening us here at the panel discussion. You can consume now some highlight, then we go into the lunch break, and I will all see you back here at 2:15. Looking forward to it. See you there. Bye-bye.
take it real soon. You know we got what you need, baby, so take it real long.
Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2024. I hope you had a lovely lunch break with a fantastic food, and it's good to have you back here. I hope you got the energy to enjoy our full afternoon program. There's a lot of highlights to come, so you can look forward to it. We will kick off the afternoon with a topic that is super important all across our industry, but not only in our industry. It's a topic of sustainability. This is what this whole afternoon is about. And we want to categorize the term a little bit so that we get a perspective before we start and dig into discussions. So in order to do that properly, we need, of course, an expert, okay? And the first person to speak here on stage is none other than Sherry Monroe, who's Executive Director of the Additive Manufacturer Green Trade Association. And she is undoubtedly an expert in this field, and therefore I'm delighted to welcome her here on stage. So please, a warm applause and welcome Sherry Monroe. Sherry, good to have you.
How are you?
I'm fine, thank you.
Good. Hey everyone, glad to be here and excited to be talking about sustainability. What a better topic to be talking about than sustainability. As Sven mentioned, I'm the Executive Director of the Additive Manufacturer Green Trade Association, and we are a global trade association focused on additive and sustainability. And our real objective is to increase adoption of additive manufacturing because we believe this is a more sustainable process when applied across the enterprise. Across the enterprise is going to be a key part of what I'm going to talk about today. Let me grab my clicker here. So one of the first things that I am quite if I can get this to go, there we go. One of the first things that I'm quite often asked is, what does sustainable manufacturing mean? And what does it mean to me, and what does it mean to our organization? This is the definition that I use. It's really about leveraging technologies to maximize resource efficiency and reduce waste. It's really just that simple. And so the word sustainable or sustainability, either one, are really rather general terms. What does that mean? Does it just mean environmental? What does it mean? It really means all those things. So whether you're thinking about environmental and social sustainability, or you're thinking about the economic viability of a company, it really still comes right down to resource efficiency. The key is, what are the resources that you're considering when you're evaluating this? And we are going to talk about that. So as we start looking at sustainability, those resources, you know, when we think about AM, we think about comparing traditional manufacturing to additive, we're always really quick to think, okay, energy, material, maybe the output waste, but there's a lot of other things that quite often don't get considered in there. Things like capital, having money tied up, time. Time is a big resource that additive can really do a lot about. Labor, opportunity, and risk. So opportunity, if you're doing this, you can't be doing that. The other thing's a risk. We're very familiar over the last few years about risks in supply chains. So that's an important one to consider as well. And when I talk about these, for people who've talked with me before, you've heard sustainability and resource efficiency sometimes used interchangeably. And there's a reason for that. For some people, I'm from the US, sustainability is not such a hot topic there at times, maybe not for a few years yet. But resource efficiency is super important. So I was at a conference earlier this year that was MIL-AM. It's in the US. It's what it sounds like. It's all about additive manufacturing, and it's military. I went just because I wanted to see, do these people even talk about sustainability? I don't know about you, but when I think about the US military, I'm not even sure they're concerned about money. They seem to have endless money, and I'm not sure sustainability is a topic for them. So I went and I said, you know, is sustainability an issue for you guys? And they kind of looked at me like, gosh, that's not really something we think about a whole lot. I said, okay, what about resource efficiency? Oh, let me tell you, they are all about resource efficiency. Because especially when you think about remote locations, forward-leaning positions, potential combat situations, they have to be very conscious of the energy they're consuming. They have limited supplies. How are they managing their resources and their materials? but also in remote locations. Like there's a project on the island of Guam that is out in the Pacific. And so they have to be very conscious of energy use, of material use, and even waste. And even if they don't care about the planet, the island is, I don't know, about the size of this stage. Where are you going to put it? So that's a concern for them as well. So creating less waste, and the waste that they do produce, being able to somehow repurpose, revert, recycle, and use that again is a really important issue. And so for folks who maybe say sustainability is not an issue for us, I can guarantee you if you talk about resource efficiency, very likely that will be an issue. And so really we could change these terms to be environmental benefits and economic outcomes, because that's really what it comes down to. Whether you're talking about money or you're talking about saving the planet, it really comes down to managing those resources better. And I will tell you, I'm not concerned about the motivation. If you tell me you're doing these practices because you want to save the planet, because you need to be economically viable, because your government is forcing you to do it, your shareholders are forcing you to do it, I always say it's a little bit like eating your carrots. I don't care if you're eating them because you like them or because they're good for you. Keep eating your carrots. And I look at additive the same way. I'm not that concerned about your motivation. Whatever's bringing you to the table, let's do more additive and let's really look at what it can do for us. So as I look at additive manufacturing, we start with 3D printing. And we look at the benefits of 3D printing itself, just the printing. So what are some of those benefits we see? Well, especially when we're talking about sustainability, for any of your family or friends, you talk about 3D printing there and you tell them what it is, they're like, oh, it's got to be more sustainable. We're not cutting away all that material. And you go, well, yeah, it's a little bit more complicated than that. And it is more complicated than that, but it does start there. So some of the benefits around sustainability and economic viability that we see just from the printing part is we're not cutting away all that material. Also, the reduced tooling required to do this. Design iteration, which is the reason rapid prototyping was the first place that additive really took off, or 3D printing took off. And so those basic efficiencies are there just in the printing process. Now, we also know for the printing process that quite often those material productions, producing powder, can take a lot of energy. So there's some areas where, okay, it's better, it may be a little bit worse, but it really takes some evaluation. And so those evaluations are happening. Next, when we look at the next ring around the set of technologies around 3D printing, that's really what we're talking about in these halls this week, right? Additive manufacturing. And so when you take 3D printing, and I know you guys already know this stuff, but I'm linking it to sustainability. So when we add all of those technologies around 3D printing that make up additive manufacturing, there's a reason we don't just call it 3D printing. But the biggest one really is about design freedom. If you walk around here, the big difference you're seeing between just 3D printing and what we have here is design freedom. What are you able to create? How are you able to create it? How can you be more efficient in those ways? So we've got unique geometries, we've got lightweighting, we've got part consolidation that you simply can't do through any other kind of manufacturing. We have the nearer net shape potential, even if you do need to do some machining. And we've got the monitoring and optimization that really makes additive manufacturing so much more than 3D printing. It's that whole set of technologies. Now, usually that's kind of where we are. When you see any analysis around additive manufacturing in terms of sustainability and economics, okay? I use the word cost to mean both, economic cost and environmental cost, because for the most part, those two things track together, not differently. And we're going to talk more about that in just a second. So this is a part that we, actually I happen to have this part here with me. This is the first research project that we did. This is an aircraft part that goes on a Boeing 767. The part on the left there, it's a machined part. There's 24 of these on a plane. They go on the engine, and that's their job. On the right is the redesigned part. So it's redesigned for lightweighting. And so we did a LCA, a life cycle assessment analysis, and we compared production of these two parts, which based on the way the project was done, kind of came out not a lot of difference. But obviously, lightweighting of a part that goes on an airplane, you can imagine the savings there, both in cost and environmental impact. Reduced jet fuel, reduced CO2 footprint. This is a great story. Now, as part of this project, that's sort of all we studied. The thing we did not study about this project was the durability of the part. And we may actually go back and revisit that project because, as it turns out, Centavia, who made this part, went back subsequent to the study and checked out the durability of this part, how long it lasts. And it's about 30 or 40% more durable. So when you're doing a part-for-part analysis, which is what we all have done a lot of and come up with varying conclusions, when you use for your LCA, your life cycle assessment, your functional unit, what are we going to compare one part to one part? It can come out very negligible. But if we go back and redo this project, instead of the functional unit being one part, it would be the life of the airplane, because the redesigned part is more durable. So over the life of the plane, we may only need 4 of these and 6 of these. That changes the economics and the environmental impact completely. And so if your organizations are looking at life cycle analysis to do one, or you're reading one, look at the functional unit, because I can tell you, depending on the project, the functional unit can kind of doom your project right from the start because you're measuring the wrong thing. So that's just something to think about there. And it was really important for this project, and it's important for a number of other projects as well. So the next layer around this, which is a part we don't really talk about quite often. So we've got the 3D printing, we've got the additive manufacturing, which we've got in these 4 halls. The additive strategies is the other part we really need to look at as we're making a case for additive manufacturing. Now, I know sometimes the term additive strategies is used to talk about, like how you're going to print the part and design it and how you're going to put it in the build volume and all that. That's not what I'm talking about. What I'm talking about is how do you apply this set of technologies across a business enterprise. So we're talking about going beyond the part-for-part analysis and things like, what does this part enable me to do? Does this enable me to get a piece of machinery up and running sooner? I'm saving a resource called time and money and CO2 impact if I have to have parts shipped in. Some of the other things that we're looking at in that kind of space is also looking at warehousing. If you're having to warehouse a lot of parts, what are the costs of that? In traditional manufacturing, which we're going to talk about a little bit more in just a minute, you have to produce in very large volumes. And so how many people get caught up in what's the part cost? All they want to know is the part cost, right? We hear that all the time. But I can almost guarantee you that when they're looking at the traditional part costs, there are costs that are not being included because they're assumed to be the same for both parts, right? We have these 2 paths. You start with, aluminum, titanium, whatever. You get the material, it gets converted differently to powder, whatever, and there's an assumption that the 2 paths come back together at some point and that everything beyond that is the same for both parts. But that's not necessarily true if you're really leveraging additive. The inventory carrying, warehousing. If you have to produce in very large volumes, those parts have to be warehoused somewhere and they have to be managed. And there are costs associated with that may not apply on the additive side. Distribution and supply chains. So if you're producing all this large volume of parts all in one location and then have to distribute those, what does that look like, and are those costs being included? And again, those costs may or may not be on the additive side, or it certainly can be minimized through some of the features of additive. So this is kind of a standard chart for looking at order quantities. So as you look at this, and this is true for additive and traditional manufacturing, right? The cost of your part, as you produce more and more and more, it decreases until it bottoms out, okay? That's true for traditional manufacturing and it's true for additive. Although for additive, quite often, it bottoms out at a much lower quantity. So The point of that and why that's so important is that you don't necessarily have to inventory all these parts. So some of the other aspects of that, and I'll just do some really quick math here, so because I know when people are talking, it's hard to keep math in your head. Let's say you need 12,000 of a part over the course of a year. I'm picking 12 for a reason, because there's 12 months. So let's say you need 12,000, or it could be 120,000, it could be whatever. If you're doing traditional manufacturing, you probably have to produce those parts all at one time, in one location, a single design, and then you have to warehouse them for the rest of the year while you burn through them. So just imagine this scenario I've laid out. With additive manufacturing, that quantity at which that price bottoms out and you stop seeing more benefit as you go with higher quantities is much lower. So instead of having to produce 12,000 parts, let's say in January to use for the rest of the year, I can produce 1,000 in January, 1,000 in February, 1,000 in March. And here's what, now you say, but it doesn't matter, I still need 12,000 parts. I'm on board with you. You need 12,000 parts, but you didn't need them all at the beginning of the year. You didn't necessarily need them all in one location. That's not very resilient for your operation to have them all in one location, and there are costs associated with that. So let's say you've made all 12,000 of those parts at the beginning of the year, and in March or April, somebody comes along and says, hey, we discovered there's a problem with this part, or we've come up with a cool addition to this design. Well, somebody's gonna say, well, hey, that's really great. You're gonna have to wait till January for us to implement that change, because we've got inventory sitting on the shelf. We've got to do something with it. So your choice at that point is suffer through suboptimal inventory for the rest of the year, or you have to trash it, recycle it, whatever, which has a big economic cost and a big environmental cost. So that ability to be able to iterate through the year is important. I know we still need to be able to do big volumes, but we don't necessarily need to do them all at once in one location, and we don't necessarily need to do one model. If you think about an appliance manufacturer, you notice how they, maybe for that brand, every knob on every stove is exactly the same? It's not because it's such a great knob, hate to break it to you. It's because they need to produce them in such large volume. So their thing is they don't want to give you any more choice than they absolutely have to because of the constraints of mass production. They have to produce things in such big volumes to get to that price that they want to use parts across platforms. But if you can produce in smaller volumes, you not only do you open up more options around inventory and carrying and distribution costs, but if you go to the product design people and say, hey, we can offer realistically, efficiently, economically, offer our customers more options because we don't have to produce a single part in such huge volumes. This has big implications throughout an organization. Now, these conversations quite often we're having with the team within a manufacturer, a big OEM that's making, I don't know, we'll use appliances again. The guys that are making the parts, they just need to get parts out. They may not care particularly, it's not really part of their responsibility, the warehousing costs or the distribution costs. But if you go to those teams and say, hey, we can reduce our standing inventory significantly, we can free up that capital and we can do other things with it. We can reduce overproduction. We can reduce obsolescence. We can reduce that, we had to print or produce a whole bunch of products but we weren't really sure what demand was going to be, or world events or other events have shifted demand, and now we've got inventory. If you can be more nimble in that by leveraging additive manufacturing, you can gain not only economically, but environmentally along the way. And so this is a big aspect that I don't think we're looking at as much as we should be in this. With our organization, again, we're a global trade association. We have members throughout the manufacturing ecosystem within AM. So everything from powder producers, printer manufacturers, software, and the end users of additive. So I kind of divide the sector into two groups. There's the technology developers, excuse me, and the technology users. And it's really important to have all of them in there because they contribute to the conversation in technology development and adoption. So based on these things that we're talking about here and looking at this additive strategies layer in particular, not only assessing the 3D printing and the additive manufacturing aspects, but those additive strategies. We're working with our members right now to create a framework for this so that when we're talking to companies about additive adoption, you know, when they want to compare, how does this compare to my traditional manufacturing? We need to be able to give them a more clear roadmap framework for evaluating that, because I can almost guarantee you there are costs on the traditional side that are not being calculated in when they're doing that comparison, because they're costs that almost feel like gravity. It's everywhere and nowhere all at the same time, and they just assume those costs to be constant no matter what. So as we develop this framework over the next year or so, we're really excited to have our members participating on that, really identifying what are those things that we really need to be looking at, and how can we better facilitate adoption. And the way we really facilitate adoption is for those people that are looking at it or looking to expand their use of additive within their company. We need to help them understand, here's what you need to look at, and here's how you can effectively compare these two things so that you can get a really good understanding and make the absolute best case decision for your business. So with that, I will say thank you very much, and hopefully you'll have some questions. And feel free to challenge me on any of this. I'm happy to do that, and love other input. If you've got thoughts on this, we can speak now, or we can also speak later too. So
at least I will do.
Yeah.
That's for sure. But any questions from the audience here? Please feel free to ask whatever you want. If not, I will. Although I must admit, I'm it's kind of strange to ask you now, because we will see you later on the panel.
Right.
And probably I take one or two of my questions away. No, don't get me wrong. So I'm a lot into lean management, and it feels so familiar. I mean, you're talking about warehouse, and the thing is, you brought the example with 1,000 per month is definitely better than 12,000 at the beginning of the year, for sure. How does it come in your perspective that it's never considered the right way, first thing? And now let me ask the second thing later. First one, why is that not recognized or acknowledged?
I think for a lot of companies, it's just not the way they've done things. It's assumed you have to produce in very large volumes. That's just the assumption. And I would also say that that number, that really high number, one of the mistakes we make as a sector also is that's a constraint of traditional manufacturing. That's not a benefit that I have to make a lot. That's their constraint. That is the thing that's hobbling them. Yeah. And then additive comes along and says, that's our goal. Like, that shouldn't be our goal to, you know, how do we put these huge inventories on a shelf? It's how do we, but not so lean to where, you know, we have issues, because we've seen what can happen with a supply chain. But you know, with additive, you can bring so much more of that production, not necessarily in-house, but more in your control. So some of the risks and concerns around lean, I think, are mitigated through additive technologies. Absolutely.
But what you do here, you're having several advantages. Like, for example, if you do only the 1,000 and you do it locally where you need it, then you have another reduction of transportation costs. That would be a next thing.
Absolutely.
By producing decentralized. That would be the next thing. My only concern. Oh, there are two questions. I stop immediately. Please, first the gentleman.
Hi, thank you very much for your presentation. I found it personally really nice, the study that you talked about different parts with conventional method and the additive manufactured part in the airplane. I wanted to ask if there's...
Put your microphone a little bit closer. So I can hear you.
I wanted to ask if there's also some studies that compares with a life cycle assessment and concerning the right kind of functional unit. Also studies the difference between these two manufacturing on demand and also the conventional, like as an example, 12,000 at the same time. Is there anything that you've conducted in this topic?
Specifically about, I'm not sure, I didn't quite get the end.
About manufacturing, the differences between manufacturing on demand with additive manufacturing and with the conventional method all at once, and like conducting a life cycle assessment on this.
Right, so those are some of the things that we're looking at. We have done some studies that reflect some of that information, and we've got studies that are available on our website as well. But that's part of what we want to do, is look at more of that and really evaluate those other aspects around that. And risk is one of them. You know, if you're going more in that lean direction, you do have risk, but you have risks when you have that stuff sitting on the shelf too. That, again, that's a risk quite often that is not considered. I live in Florida. We have hurricanes all the time now. So even just having inventory sitting on a shelf has risk, right? And so, but is that getting counted in? It might get counted in immediately on a lean type of strategy, but there's equally risks on the other side that may or may not be factored.
But my recommendation to you, we will step deeper into the topic in our panel discussion, like in about 25 minutes when we join the stage again, and talk a lot more about sustainability. Unfortunately, we were running out of time, but I think Sherry will answer your question right beside the stage without any problem. So ladies and gentlemen, a big applause again for Sherry Monroe. I really enjoyed it so much. Sherry, what such a wonderful presentation.
Thanks, Sven.
So, ladies and gentlemen, at the live stream, enjoy another few highlights from the fair. I do all the time because I can't walk around, so you should do as well. In about 5 minutes, we will see us back here for another exciting keynote before we step into our panel. So stay tuned. See you in a few minutes. Thank you.
Hi Louise, it's nice to be at Formnext again this year. I think in difficult times where the market conditions are difficult, it's very good to have a trade show to meet the visitors and to exchange ideas and trigger the business. Last year we launched some great innovations.
Yeah, we did. And I think in those challenging conditions, productivity is really key for our customers. So last year when we launched the RenAM Ultra series, with Tempest technology, we really launched productivity with no compromise in quality.
We were really successful in various industries. One of it was aerospace, another one energy. I see Mark over there, our business manager from Spain. Hey Mark, we just spoke about our success in aerospace and energy industries. What can you tell us about that?
Exciting times, definitely. We now have machines with 1 laser, 2 lasers and 4 lasers that with technologies such as Tempus and Simlanes are able to give the capacity to our customers to build at a very high productivity that they need with a real cost per part.
It's fair to say we show a very strong evolution based on our innovation which we launched last year.
I have here a good example from Morpheus Designs, that is kind of regulated sectors that they are capable to use the technology in the best possible way.
So what is about our hardware, the new 2 laser machine?
This is a very good example. RenAM 500D, the dual laser is able to give the customers 3 times the throughput of a single laser machine.
That's great stuff. Thank you, Mark. Another big success is the medical industry, where our increased level of productivity helped to make it really in series production.
Yeah, exactly. Chris, can you tell us why medical device customers choose Renishaw?
Sure. Renishaw 500Q Ultra machine users are able to produce high accuracy lattice components which have consistent mechanical properties across the entire bed of the machine. When you combine this technology with Tempus, 4 lasers, a compact machine footprint, and then also competitive pricing, you've got a great offer for the customer.
Thanks, Chris.
Thank you very much. That's great.
Wow, it's really great to see how AEM makes it in various industries, and I'm really looking forward for the next couple of days here at the show.
Yeah, it really has been a great start to the week.
Hello, ladies and gentlemen. Welcome back here on the industry stage at Formnext 2024. Day 3, we are keeping the pace. We have fantastic topics for you to come. And we stay this afternoon with the topic of sustainability. And it's interesting. Yesterday in our after-work talk, someone said, countries need a clear vision in order to get things realized and to bring things up to speed. And today in our morning talk, there was Itu from DMAC who made clear that Finland has a clear and chosen strategy to put focus on sustainability as its guiding vision. So it's only logical, of course, that we invite someone to introduce us a little bit more into sustainability in Finland, what is going on. So please join me in welcoming Advancing NM, Finland's Sustainable Pathway and Nordic Collaboration, who is Dr. Sini-Metsä Kotalainen, Head of Ecosystems at DMAC OY.
Thank you so much. So thank you for the introductions and greetings from Finland. So as said, I'm Sini-Metsä Kotalainen, Head of Ecosystems, working for DMAC, which is a quite small company in Finland. Basically, we are orchestrating different kind of industrial ecosystems, and FAME is one of them. So FAME is Finnish additive manufacturing ecosystem focusing on AM. And today I'm focusing more on sustainable topic and of course before that a little bit going through what our ecosystem is doing. And a little bit about my background. So I started to work for DMAC about a year ago, and before that I had quite a long research career at VTT Technical Research Center of Finland. So 20 years I was focusing on research and 15 of those focusing on AM. So I do know something on AM. But perhaps I'm not the LCA expert or that kind of person, but I'm a green people from a quite green country. We are living in the forests basically, so that's one advantage of Finland regarding this topic. So as said, I'm giving you the basic facts on FAME in the beginning of my presentation, and after that I'm more focusing on this sustainable AM topic. So let's start from the FAME, and actually these photos are taken by sun. Those are all from Finland, so you are also seeing that what kind of nature we do have in Finland. It's related to environment and sustainability as well. But Finnish additive manufacturing ecosystem is the main AM ecosystem in Finland. It was established in 2020, and it's very industry-driven ecosystem, but we also have incorporated the research organizations in our actions actually this year. Our idea is that it's quite experts from experts ecosystem, and our role in DMAC is to facilitate the ecosystem activities. But the idea is that the industry members are doing the work basically. And I would say that our motto could be that come with a problem and live with the solution. So we do believe in the power of collaboration. And also not only inside Finland, we are open also for companies outside of Finland, and we are aiming and strengthening collaboration, especially with the Nordic countries, but also other countries as well. We are having our own strategy. The companies have built the strategy and the ecosystem activities those are highly based on openness and open sharing of the information and also trust. So that's really important for us. But then going towards the sustainability, or actually our vision is sustainable AM is Finland's competitive edge. So I would say that that's quite natural for Finns to be sustainable, and later on I'm showing some figures that you will get an understanding what I'm talking here. And also education, we have long traditions in Finland to have high education possibilities, and also that's important topic regarding of educating AM experts. So we want to be one of the best locations for that as well. Here you can see all of our members, so 60 members at the moment covering the whole AM value chain. And also, as said, we have all the main research organizations focusing on AM also involved in our actions. And where we are growing at the moment especially is the bottom part of this slide, so the applier companies. So the companies who are utilizing AM in their production or in their products or aiming for that. In the nutshell, we organize quite a lot of activities for our members, and of course our members are organizing the activities, but we are facilitating those. So knowledge increase, very important part of our activities. We have built an information sharing platform for our members, and we have collected plenty of information there. We organize different kind of trainings and other webinars and so forth. So we want to our companies to know what is happening in the area of AM. We have an AM campus, which is a learning environment on Metal AM. It's located in Vaasa, open for all companies, and also marketing and visibility, creating new AM-related data and so forth. Very important topics for our ecosystem. And of course, international collaboration. So we are doing here, for example, and we are having our own Finnish pavilion upstairs, so welcome to visit that. Different kind of co-creation activities, very important topic, as said, it's from expert to expert, so we are facilitating those kind of activities. And a few words on the status of AM in Finland. So it is not a very large business yet, but it's growing. So the growth rate has been quite high during the past years, and it is expected to grow. And we are having business both on polymers and metals, and we are having quite nice number of industrial scale AM machines in Finland. So just for you to remember that Finland is a quite small country of 5.6 million people, so for us this number is quite high. We also do have quite remarkable number of 3D printing service provider companies in Finland, and actually I think it's a little bit different than in other countries because of these OEM companies and applier companies for AM. They are highly collaborating with these service providers. So instead of buying own AM machines, they trust with these 3D printing service providers and do collaboration with them. Then we are building this kind of strong Nordic collaboration, especially with Norway, Denmark, and also Sweden. It is happening in Finland also that we are focusing on research on AM, covering wide variety of different kind of topics. But let's move on to sustainable AM. So a couple of key figures from Finland. So I believe that this is quite familiar to you, this report of United Nations. This is the Sustainable Development Report, and actually Finland is having the highest score at the moment of all 193 countries. So this is something that we are very proud of. Finland also has ratified the Paris Agreement, and we are aiming to be climate neutral by 2035. And when our greenhouse emissions are coming mostly from energy sector, agriculture and industrial processes, part is 11%. When we are talking about the sustainability, quite often we focus on environmental impacts. But I would like to highlight that it's very important to include all of these pillars of ESG, so also the social and governance pillars. And those are the ones, referring again to this Sustainable Development Report, especially in Nordic countries, we are having these things in pretty good condition. Then again, a couple of more key figures from Finland, so explaining that why AM is important for us. Actually, manufacturing sector is important for us. So manufacturing sector is about 60% of our gross domestic product. This is the number of 2022. And one more figure for you before moving on. So this is showing the carbon intensity of electricity generation. So we are having quite light color there in Finland and also in the Nordic countries. And this is showing that we are having quite a lot of renewable energy in use. And that's actually quite important topic when talking about the environmental impacts of AM. So when we are comparing AM and conventional manufacturing, these are quite obvious if you are AM experts. So benefits of AM are naturally coming from design optimization, better parts, better performance and lightweightness. And also this is related to the manufacturing phase and emissions coming from that part, but also from the use phase. And actually the effects of the use phase can be quite remarkable. Of course, it's better to repair than manufacture new parts. AM can be utilized for repairing, and also it was Sherry talking about this on-demand manufacturing and these kind of things, so very, very relevant for AM as well. And also in the design phase, I would like to focus on also that part that when the part comes to its end, so what to do with the parts. So we can design the parts so that those are easier to dismantle. But points of impacts regarding especially AM. So we know quite well that it's quite energy intensive process. So it does matter which kind of electricity we are utilizing in manufacturing. Also, it does matter if we are recycling the gases. Gases actually are utilized quite a lot of in the manufacturing phase, or phases actually, also in the powder manufacturing. It does matter what kind of material we are selecting, so if we are able to manufacture a part utilizing polymers instead of metals, it's always better. And it does matter that how we are utilizing the AM machines, so how we do the nesting and do all of the operations. Then we go to the measurement of these environmental impacts. So there are some of these LCA tools available. But we have noticed, and actually I'm coming to our showcases a little bit later, that the results are not always comparable. And I think this is an issue at the moment. And also it's an issue that the results are not directly comparable when we are calculating the environmental impact of conventional manufactured parts. we have these LCA tools, but often we utilize also databases from where we get the numbers for the calculations. And actually, we are lacking some AM-specific numbers in these databases. So I would say that we are not there yet, so a little bit further development is needed. And especially I would focus now on the, let's say, defining the basic principles, general rules that how to make the assessment. And I would drive to that direction that we would do the assessment every time in the same manner. What we then do in FAME, Finnish Additive Manufacturing Ecosystem. So actually we have built this kind of sustainable AM roadmap, and we started the actions already last year. I'm not going into every detail of this roadmap, but just showing that we do have this roadmap, we do have our targets, and we have a direction where to go. And our goal is that by 2030 sustainable AM is Finland's competitive edge. This year we have focused on sustainable AM training. We organized for our members, and then we have built an sustainable AM handbook, and also we have done a couple of showcases. Those are also visible in our booth upstairs. This is just showing you what were the modules of the training we organized in collaboration with Amexi. And the idea was that all of our members would get an understanding on this environmental impacts of AM, and also how these LCA tools are working, and what to take into account in the calculations. And this is just showing the table of contents of this sustainability handbook. So it's a small guidance for our members that what to take into account. And finally, coming to our showcases on sustainable AM. So here we have a couple of parts, one of coming from Valmet and one of Wärtsilä, and these are quite different parts, and we can talk about the details later on, but showing some of the figures to you. So basically, in both cases, we have calculated the environmental impact of conventional made part, and also then we have a little bit optimized the part in the Valmet case. More radical optimization was done in the Wärtsilä case, but then we have also done the LCA calculation for these AM parts. And actually we utilized also different tools for the calculation, and I can show you a comparison in my next slide. But basically, if we can see what was the end result. So in these both cases, we were able to reduce the CO2 footprint. And it's quite natural that in this other case, the Wärtsilä case, where the original part was 2.3 kilos, and we were able to have the same functionality with a part of 40 grams. It's quite obvious that the CO2 reduction was quite impressive. But here is the table where you can see comparison of the results of these different LCA calculations. So the first row is showing the conventional manufacturing results, and then the last three rows are assessment results of utilizing different tools. So we utilized EOS, AM Power, and Amexi tools for LCA calculation. And here you can see that there is quite wide variation in these numbers. And there are reasons behind that, but my main message is that we should be able to compare these results when communicating that how sustainable AM is. And we are not there yet, so we need some further development. So not going into details here, but we can discuss it more later on. So finally, some key takeaways. So I would highlight that when talking about sustainability, let's not talk only on environmental impacts, but let's also focus on these S and G letters of ESG. And also, I have seen quite a lot of cases where AM wasn't that sustainable. So it should be based on facts when we are communicating that how sustainable AM is. So it should be based on calculations, some numbers, and so forth. And as shown in the tables, results are not yet comparable when utilizing different tools. So especially this LCA part, it's still under development, but it's progressing, and I'm very happy about that. And just to highlight why especially we Nordic countries, we see that it's quite beneficial for us to make this AM manufacturing in Finland, because we are having this renewable energy in use, and we can produce the parts more greener than in many other countries. So electricity matters, so what kind of electricity is in use. And finally, this is very important part, so we do believe in power of collaboration. So within our ecosystem, but also with other ecosystems, other countries, other companies, from people to people. So that's very important in fostering this huge topic like sustainability. So thank you so much. Please come to visit our Finnish pavilion upstairs.
Big applause, Sini. Great. I mean, this is the impression that we have from Finland, right? Always snow, always dark.
Indeed, indeed.
It is?
It is,
okay.
of course.
I'm sorry
Actually,
for that.
at the moment, we do have snow, and it was too much snow, for
Okay.
one day. So
Well,
we
lucky
had some
you.
challenges.
You're missing the snow.
Yeah,
so
indeed.
Basically. So
We
first of
enjoyed.
all, thank you for the presentation. And my question to the audience, any questions from the audience to the topics here on stage? Take your time, think about it, because I have two. So first of all, Sini, as I mentioned at the very beginning, and E2, is that correct? Or E2? E2.
Yes.
He mentioned it this morning as a colleague of yours, I think, right?
Yes.
He mentioned that really it is a vision of the country to focus on sustainability. Does it make it easier in your work, so approaching companies or making collaborations, that the country is behind it with their focus?
Yes, indeed, of course. So it's quite natural for us. So as I said, we have green people from green countries, so it's a benefit of us. But of course, when we are talking about, let's say, AM business, it's quite small. So the effects are not that huge.
Yeah.
But of course, we are driving for that.
Yeah, very good. And another question, I mean, you mentioned the different methods of the different companies in order to do an LCA assessment. And we have Sherry later in the panel. We can squeeze her as well. So,
yes.
and ask her. So what are the next steps in harmonizing that? I mean, that would be necessary, wouldn't it be? I mean,
yeah, indeed.
If you want to work internationally and you come to, I don't know, to the US, you have, let's say, a new production method or new technology coming up or a new application, and you want to compare the LCA, it shouldn't matter whether it's your organization or Sherry's organization, right?
And, very good question. And we don't want to do it by ourselves.
Yeah.
So this is a collaboration thing. So of course we have started this in the Nordic countries, but now we are looking for any other countries to join us, and let's do it together. So I think that we do need some funding for it, common funding, common resources, clever minds and so forth, but we need to do it together. And I think we have already quite a good basis for that. So we are having very functional, good LCA tools, but some adjustments perhaps are needed.
So the target is then a common standard for LCA. Would that be something?
Yes, indeed.
Okay, that's it. Like the new ISO for LCAs, basically.
Indeed, yeah.
Okay, very good. So, what is about the other countries? I mean, you have Nordic countries, are also Sweden, Denmark. Is there already a strong collaboration on sustainability?
Yeah, and I would say that of course Danish AM Hub, they have built their own tool already, and it's very good tool. So of course we are driving collaboration with them, with Norwegian partners. It's quite natural that we have started their collaboration in the Nordics, but now we are coming to the south, and of course I think it's a driver for other countries as well that we would have these common practices in these calculations.
And it's great that your region is pushing that. That's fantastic.
I think we are pushing, and it's because of our traditions and because of our good position when it comes to renewable energy and these kind of things. So those are important for us.
I tell you what, see, I'm so much looking forward to discuss with you in just a few minutes. At this moment, I say thank you very much for the presentation. Ladies and gentlemen,
thank you.
You can enjoy some minutes of highlights now. And after that, we will see the guys here again at our panel discussion regarding sustainability with a few more experts on stage. So stay tuned. See you in a few minutes. Thank you. Awesome. Thank you.
AI Build is a software company. It provides a very advanced platform to generate advanced toolpaths for industrial machines. We have parts from our partners that we have done in collaboration. We have live printing with the KUKA cell. We also have our collaboration with the CNC Robotics, Sika Materials and Total Machining Solutions in UK, as well a beautiful tool from Ingersoll, the Kamoji group, as well some beautiful parts from Fronius. At the fair we offer our software AI Build version 3, which is what we have been working for over a year now, that we are releasing today at Formnext. We have a few capabilities that we are releasing, from automation on making molds that we called Mold Designer. So now the user is able to only import their A surface and automatically create ribs and forklift holes for the manufacturing process. The most important feature of AI Build platform is our unique architecture. It's based into visual programming. That means that we can have very flexible control of the engineering workflows. We can have engineering workflows that are very simple to use, but also very advanced for very complex processes and applications. AI Build is a software company, and the benefit for our customers is our team. They will have close communication with our team at all times. They are specialists, and that reflects on our software. Come to our booth. Our team is here to welcome you. Please visit our website ai-build.com.
Here at EOS, there has been an unveiling ceremony of a new product, and for that reason we're going to grab us the product manager to talk to him about sustainability.
sustainability for EOS is a key pillar in our corporate vision, our corporate mission of responsible manufacturing. And sustainability entails a multitude of aspects. It's about zero waste production, and with new materials running on this solution, being able to reuse 80% of the material, you achieve a zero waste production. So when speaking about materials, we continue to serve the existing EOS materials. The world of the nylons, the world of the TPEs, the flame retardant materials, and so on. But we're also introducing 2 materials that are optimized for reuse. And it's not only about the material reuse, it's also about efficiency in your production. Printing faster means more output at the same time, paying into an improved CO2 carbon footprint, and this is what helps you, helps us, helps the industry be more sustainable.
I might have picked a slightly unsuitable outfit for a business event like Formnext 2024, but I might just find somewhere where it's exactly right. Follow me. Wow. Hi, I'm Sylv. What's this?
Hey, I'm Cosma. This is a moon rover. Students like me built it to take part at a challenge called NASA Rover Challenge in the US.
I'm impressed. Can I jump in?
Yes, of course.
Take a ride?
Take a seat and let's go.
Wonder how fast this goes. I'm a bit scared.
We'll be surprised.
Hold on tight. Ah! Cosma, does it have a horn?
Of course.
This is fun, it's great. Woo! Do you need a license to drive it?
No, on the streets you don't need any license, but you should be sure that you are able to drive this vehicle.
Yes, well, it's pretty hard, you know, it's good leg work.
How was it?
It was a hell of a ride. That's great, thanks. Oh, wow, thank you so much. That was fun.
I'm happy you liked it.
Loved it, great. Are any of these parts 3D printed?
We now mainly use it for prototyping, but let's see what the future brings.
Let's see what the future brings. Who knows? In the future there might be entire carts printed in 3D, except for the wheels, of course.
Hello, ladies and gentlemen, and welcome back here on the industry stage at the Formnext 2024. And if you were watching carefully and you listened to Sherry's presentation, you have heard that we don't have to see sustainability only in an environmental perspective, but also in different perspectives. And this is what we want to do here at the panel. And therefore, I invited guests and experts from totally different areas. Let me introduce to you my guests. So, we have Professor Dr. Christian Arndt. At the very beginning, Professor at the University of Applied Sciences, Aachen. Christian, good to have you.
Great to be here.
Then we have Markus Eriksson, who is Senior Researcher at Rise Mobility and Systems. Is that correct, Markus?
Yeah.
That's cool. Then you just heard a fantastic presentation, by the way. Dr. Sini, your last name is really hard to pronounce. Metsäkortelainen.
Very good.
That's good. You are Head of Ecosystems and Senior Ecosystem Lead at DIMEC. It's DIMEC. OY. And to my left, Sherry Monroe, already presented Executive Director of the Additive Manufacturer Green Trade Association. Sherry, good to have you here.
Great to be here.
Christian, you are the most neutral person here on this panel, so this is why I assume. So this is why we start. So the other three are strictly focusing on sustainability. You are not, kind of not, yeah? So I ask you, how important is sustainability in the student education and how big is the interest on the other side?
Yeah, that's a great question. So I personally believe it is extremely important. But it is also not so easy to teach it because it is like touching every bit of the technical studies and every part of the things that we talk about during studies and that we try to teach. So we decided actually some years ago that we would not go into having singular topics like one or two modules on sustainability.
Okay.
But we were looking into integrating the topic of sustainability on the ecological level, but also on all those other aspects like social aspects and also security aspects and things like these, and try to introduce them into every single module, because all of the topics that we are talking about are, let's say, relevant in order to come to a global sustainable solution.
Sorry, in your answer, Christian,
Yeah.
before you finish,
Yeah.
I already hear some problems in definition, and that's what you tackled today, Sherry. Yeah. So it's not that easy to, let's say, describe sustainability, and everybody has a different understanding. What is the understanding you have, and how do you incorporate that? Because you said we are taking all the different perspectives, right?
Yeah, so I would say that in the end we have global challenges, and many of them touch the different aspects of sustainability. We believe that only we have to think about solutions, and many of the solutions are technical. This is what we can talk about. There are other parts of the problem which we cannot really touch on a maybe more political level or things like these. But from a technical perspective, there are many possibilities. AM is going into this direction in many areas, and this is what we try to bring into it. So in a certain way, every time that you think of a technical system, do not only start by technical specifications, but directly start by how does it influence sustainability on all levels. This is maybe the most important thing.
And what I really liked, first, Sherry mentioned that it's not only about always environmental, but also saving resources. And we should not forget, this was the basic thought when sustainability came up as a word.
Yeah.
It was about saving the forest and the amount of wood we have, and not cut more than we need, basically. That was the initial thought. So, Sini, and you mentioned the 3 dimensions that should always be considered, and not only one. Coming to you, so looking a little bit at the Finnish manufacturing ecosystem, how do you push the topic inside your members? How is that pushed from your side? And are there already some key successes? I mean, you're doing the LCA, similar to AMGDTA, but this is like in a very early stage, but what are like really successes in terms of sustainability already?
Yeah, if I start from your first question, so what we can do in FAME and what are the actions we are doing in FAME. So if you were listening to my presentation, I showed you our sustainability aim roadmap. So we have quite clear vision where we want to go, and we have developed a path to go there and reach all the targets that we have defined for us. But that is not an easy route for us, even we are, let's say, fostering the topic, and we have been fostering the topic quite a long time, and especially in Finland. But I think that's good that we already have this kind of definition and the path that's where we want to go. And I think that the successes of this year have been this training organized for our members. So they now know the basics on sustainability things and about different kind of LCA tools and how to make this assessment, what to take into account, what are the constraints there. So I think this kind of knowledge increase, it's very important topic there. And then we always try to make everything quite tangible for our members to really understand the things. So that's why we are doing these showcases. I presented in my presentation a couple of those ones. If you weren't there, you can see the showcases in Finnish pavilion. But just to make it tangible, that what are the differences between conventional methods and AM methods. So very important topics. But then what are the success stories? A very good question. I think that our success at the moment is coming from there, that if we are really calculating the environmental impacts of AM, we are getting quite, let's say, good numbers in Finland, and it's based on the energy that we have green electricity in use, and I think that's the thing that we do have at the moment. That's very good for us, and of course I'm looking forward that it's more common to other countries as well in the forthcoming years, that they can also be this kind of green energy and base the production on that.
Difficult political situation, and we won't raise that topic. There are a few countries like yours and ours, sorry, where it might get difficult in the near future. But thank you so much, Tine. Markus, the funny thing is when we got known to each other, you explained where you're coming from. And this is really something that Sherry mentioned today, or in our final question round, we're talking about transportation, and you have a background in truck business, basically. That's the funny thing. But today, let's talk about today. What role do institutes like RISE play in bridging the gap between like innovation, in sustainability? There are so many ideas and things, but bring it into practical application in manufacturing. So what is your part in that?
Well, we look upon it as a journey. And then you need to meet your partners where they are in this journey. Are they in the beginning, or have they come far? And depending on where they are, then of course you need to approach them with different means. If we were talking about AM, initially it's about training and getting to know the limitations of the technology, etc. But then, of course, from there you can start to test and practice. So we have testing facilities where you can start to build your knowledge around that, to explore the possibilities. And then when you start to find your applications, of course, then you want to scale. But as you know, scaling costs money. And what do you need then? You need a business case. And so a business case is one area where many of our members today are struggling because they want to scale their initiatives. And then they need to calculate on more aspects than just to cut cost. So sustainability is one parameter that they have been asking us for support to develop methods to quantify from a sustainability, but also, as Sherry has been talking about, on what is the value of time, what is the value of availability. So, and then of course, it's much about facilitation too. So after a while, they start to excel. And then it's more bringing people together and let the magic happen. So that is how I see then the role of RISE and how we can support our partners to grow into this.
And that's what I really like, and there I see the connection to your presentation, Sherry. I mean, let's talk honestly here. We need a business case behind it, and that's the funny thing. If you're talking about sustainability, that's why I loved your three-dimensional aspect. We're always talking about environmental things, and that's like the common understanding. But in the end, it must be finance, and it must be feasible on an economic scale. But when you look then into additive manufacturing, there comes the magic, like saving warehouse space, saving transportation, stuff like that, saving material use. These are all things that really push also the business case into a positive direction, basically, Sherry. That's it, or?
Absolutely. And I think the more we can get those complete business cases, that's, we were just talking a minute ago, companies aren't adverse to implementing new technologies. They don't mind change. They just don't like uncertainty. They want to know what this is going to do for them and how it's going to impact them. And, in the U.S. in particular, you can't talk about sustainability by itself. The first question is what's it going to cost? So by tracking those together and seeing that they really do track together, they're not at odds. If you're saving money on energy and on material and on all these things, you're saving money, but you're also saving environmental impact, although it quite often is not getting captured, because if your objective is money, which is fine, these other benefits are happening that maybe just aren't being accounted for.
Yeah, that's a funny thing that we don't take that into consideration because sustainability would often lead to money saving at the same time. So that's a funny thing. Christian, I mean, you are researching in how to save material, how to save energy, how to optimize the technology, how to reduce cycle times, whatever it is, it's all in your research field and your educational field. Where is the biggest, the biggest chance of doing something for sustainability? Where do you see the focus right now?
I think the most important thing is to see the business cases, as you said, holistically. I think this is the most important thing. In nearly every case that I saw which was successful, there were certain parts of it where you have to invest more. Sometimes even more resources, more money anyway. So it's an old story talking about life cycle costs and things like these. I have a strong background in the tooling industry, and it is always the same. You can invest more in a very good tool, and you will save so much money later in the production itself. Or you just look at the initial price of the tool, and you will definitely not save anything later.
Yeah.
And it's always the same story. So you have to accept that there is a part of the whole value chain, which you look at, where you have to invest more. But if you look at the whole thing, and there AM is a big facilitator to do so, if you look at the whole thing, if you take distribution into it, if you take reduced overproduction into it, sometimes if you take raw material into it, you will save something. If you look at the design of the parts, all these things are extremely important, but there always is a part of the story where you have to invest more.
Yeah.
And if we just consider this part, in many cases that's it, because the broader view is not there. If you just look at this part, you will always say, okay, it's not a case, it's not a business case because I have to invest more.
Yeah.
But you have to see where you're
and here is a part of the dilemma, because I mean we have many different actors in a supply chain. So let's say that actor number 2 are investing in longevity or in increased durability of a part. Who is going to benefit from that investment?
Right.
Is it the person doing the investment, or is it someone else? And here you need to bring your investment and also the cashing in into the same wallet, because otherwise, why should you do that investment?
Yeah.
So that is a part of the challenge here, then to work within this system that we have today.
And furthermore, I mean, as you said, there's a whole process chain behind it, a whole, let's say, money increasing business case behind it, where probably, let's say, airplanes, where you had this part in your speech. Let's say we reduce the amount of being repaired. Then it's good for the airline, it's good for the producer of the part, but it's bad for all the service providers in the world. They wouldn't push it, I assume.
But here I see there's a great benefit of AM, where as a manufacturing technology, it is quite different compared to the other ones, because it has a potential to change how we do things, to change our processes. And one term that I'm really fond of is supply chain compression, because it starts to push the supply chain, making it smaller, leaner, and meaner, which also solves a part of that challenge, that the one who's making the investment is also making the profit. So there I see that AM as a process changer is a great or enabler.
But let's talk quickly about feasibility, okay? Because you mentioned this example with the 12,000 pieces compared to the 1,000 per month. So my question would be, we are talking about industrialization all the time here at the fair. But are we at that point? Because we talked about the traditional thinking of we need to produce in order to get it cheap.
Right.
More pieces, cheaper product. That's basically the traditional thinking. So if we are able to produce the same amount with additive manufacturing in not the same, but at least an acceptable amount of time, then that would be a business case. But are we at that point? Is that, if you do the LCAs, you see, okay, we can compare it, or is it still, you have to take other aspects into consideration?
Yeah, well, I think one of the challenges there too is you can look at an individual part and say, oh, we could do this differently, but if you're building an entire assembly, are the other parts being managed in a similar way? And so how do you move that along? You know, that one part may last longer, but if it's part of an assembly that has to be changed out more frequently, you may have benefit that you're not even getting any value out of. So it really, you know, but if you can make the case for it as a, you know, example part, then they may say, okay, well, now we see how the benefits around this, you know, let's adopt more so that we can actually push it forward. But yeah, but this is the way technology and innovation always goes, right? This is the way it happens, and it's bumpy and yeah.
It's a change in thinking, and that's would be my next question to you. So if there is a country that puts focus on sustainability in whatever dimension we are talking about it, okay? So, and we need this thinking in AM, which we discussed yesterday heavily, yeah? So forget about thinking in traditional way and try to replace something, start thinking in AM. Is that happening then more easily in Finland, for example, because they're thinking directly in the aspects of sustainability, and AM is the most logical solution? Is that something you observe or not? Not at all.
Really difficult question to answer, but it might be so. And I have noticed that people working in the AM area, those are very clever people, and I think that we are having certain creativity in all of we do. So it might be so, but yeah, I think it depends finally on the case.
Yeah.
And I would highlight that AM is still one manufacturing technology. There are plenty of other ways to manufacture as well. So it is definitely for all. So we should manufacture only utilizing AM. So we need to find the business cases. Also, we need to find the cases that where we can highlight the sustainability, for example. But yeah.
Yeah, but then we need success stories, right?
Yeah, indeed.
I would like maybe to add one thing. So I always said, don't think in AM, think in part functionality.
Yeah.
And reduce, let's say, the limits that we have been teaching engineers for many years, and we have tried to stop teaching them. Also, AM has limits, but they are completely different. So start thinking the functionality of the part, and then think about which is the best technology or process chain to make the part. And in many cases it's AM, but in many cases it's not. We have many cases where, for example, we started, or we reduced this small area of possibilities by saying, okay, we could do it by AM. It was designed in a completely different way, and in the end it was a fine casting part, for example. So there are many other technologies which you can use depending on the amount of parts that you have to make and all these things. But AM is a great facilitator to reduce the early limits for thinking in functionality of a part. Yeah. And we see many examples here which are like this, where in many cases I would say, okay, if you go into a serial production, maybe it's not AM anymore, but that's not the problem.
Yeah, but probably it's part of the solution to get there, right?
It is a big facilitator of the solution.
And you have a very interesting consequence of what you're saying here, because I mean, on the inside of the or the incoming material. So if you do what you just said, then of course it will have an impact on the material that you're requiring, and also the number of sub-supplier that you need, which is an example of this supply chain compression. That
absolutely.
You don't have to do those inbound transports anymore. You don't need to have all those different sizes of material in your stock in order to produce that particular. You can reduce the complexity there, and that is just on the inbound side.
And I think you can also do a little bit of just a mental exercise. Instead of saying, you know, if I want to print this, is this a good candidate to be printed? just as a sort of exploratory thing, say under what circumstances would it make sense to print this?
Yeah.
Our board chair, Brian Neff, always says, you know, printing a fork that you eat with would be a terrible use of additive. And then I joke with him, I say, well, unless you're on the space station and you need a fork, you know, like there are instances in any part where somebody would say, this is not a viable candidate for additive. Well, it might be under certain circumstances, and what might be the, you know, remote location or the supply chain issues, or in what circumstances would it make sense to make this part? Because then you start looking at it just from a different perspective, and you come at it, and it can be very informing of just how you approach this and find those right applications, because it's very application specific, but it's not just the part, it's all those circumstances around it. Yeah, so there's a lot of ways to look at it.
But that's the next question I have. Isn't it also a matter of the objective that is behind, which brings us probably back to sustainability? So defining the objective you want to achieve, let's say I want to use the bottle in the spaceship, that's an easy case, because then you need a 3D printing machine.
Yeah.
Otherwise you won't have a fork on the space station. That would be the next question. If the objectives remain the same, save cost by any means, then it's hard to transfer the thinking into a new dimension, right? So, and my question to you, Christian, you can answer it right away, is are we able to remodule the thinking with education, for example?
Yeah, I think there's one important thing to know. In many of the traditional businesses that we do, we think that we make it the cheapest way, but we don't.
Yeah.
Definitely not, in many, many cases. Because those distributed, long, let's say, many different players we have in the supply chain, everyone tries to make the best out of it for himself, but we don't really have the transparency what would be, let's say, the globally best solution for a part. And I think my point is, we have to think about transparency. We have to think about data in the end, about better understanding what is the benefit, also in terms of cost. In the end, it will only work by cost. If we talk about sustainability and we say, okay, it's the more sustainable part, maybe we get a really small portion of the markets where people are extremely aware of it and so on. That's nice, but it's more story. Let's say the business part of it is to save cost. But there are many examples where we do this, but we have, again, to look at the global thing. So I'm really convinced that we are able to do so, but we have to also change the thinking in the industry, not only in terms of technology, but also in the way that cost is defined.
That would result in the importance of creating standards and LCA assessment, or in life cycle assessment, because if you want to have transparency, you need to have comparable figures. Otherwise, as we could see in your chart, I mean, if I would observe it as a manager of a company, I would say, hey, don't get me wrong, as long as these 4 figures are different, I'm not interested in. That's a little bit the point. But Marcus, I want to, because you said we are reducing the number of suppliers or decreasing the supply chain a little bit. Wouldn't you think that there are a lot of challenges to achieve that, because there are so many that don't want this? So are there already some experience?
I said that there was a consequence. If you design for AM, you get a consequence, and that consequence is that if you are reducing the number of parts in a function from 50 to 10, then you will have 40 less parts that needs to be shipped, produced, etc., etc. That is just a pure consequence. So there's nothing that anyone can do about that if you take that path. But what I've seen when it comes to this, how do you calculate the gains and the business case around AM? If we take many of the big companies that I'm working with, then we have the R&D department, we have the manufacturing department, we have the logistic department, we have the aftermarket department. So taking back this question about who is getting the gain out of this chain, now you're still within the same company, but it's different departments. Is it the manufacturing guys who are measured and their salary is depending on how successful they are? Or is it the aftermarket people who is measured on the availability and the sales? And coming back to this with time, because that is one key factor that we have found where you can find a lot of value, both from a sustainability perspective, but also from an economical point of view, is to cut lead time, especially in global companies then. And that's why I'm so super interested in decentralized production, which is then possible with AM and other technologies, I might say.
So the funny thing is, before we come to a different topic of sustainability, my question to you is, I work a lot with C-level managers that have to decide about introducing a new technology. And wherever I am, of course, I tackle additive manufacturing. So if you're addicted, of course, you bring it up. Yeah? And the answer is always the same. So no, our technology cannot be replaced with it, or we can't produce that much parts in that time, or quality is still not good enough, etc. So many, I don't want to say prejudices, but probably it is. So what is the key factor to convince those guys? Because, you know, we can talk about sustainability as long as we want, and between us, we can exchange success stories and business case, whatever we want, as long as you don't get the C-level members on board saying, yeah, I trust in AM to be one possible solution, not the only one. So what are you doing? I mean, you're working in organization, bringing together members, industry members. How do you convince them? Please give me an answer. This would be awkward. This would be an awkward moment in our panel if we stop now.
We'll find one.
Okay, so stop it. No, Sherry, I mean...
I think being able to give them reliable information that they can trust, that is complete, that's applicable for them, and they understand how this will impact their flow, and help them be able to see all those impacts, like you said, whether it's different companies or different departments within a company. Everybody's got their little area that they want to protect, and so you really have to be able to communicate that. And it's like change management in any other way. How do you roll that out within a company? How do you get buy-in? How do you have confidence that this is going to work? I think you run into those same things, but reliable information that you can trust, I think, is the biggest part of it.
And you probably need, sorry, Christian, one question.
Yeah, maybe just one additional idea. I'm really a technology guy, but today I think I would not start talking about the benefits of AM. I would start maybe asking the question, do you want to reduce your stocks? And also, do you want to make your parts better than those of the others in a certain way? Do you want to have kind of a competitive advantage by better parts? Start thinking about that, and then you can maybe find one of the solutions. I don't know if it works.
I can tell you, I do that.
I know.
The thing is, 1 second, Marcus. The thing is that they won't believe you, because you know what? We are telling them that for 20 years now. That's a little bit the problem, and there are too few real successful business cases. They're coming now in a really high speed, so we are getting more and more of those. But as far as I remember, we are talking too often about the benefits, and they are not showing up. That's a little bit the problem. But Marcus, please.
But it's a little bit like, how do you win the Olympics? How do you stand and be number one there? And of course, it is a long journey. And it always starts with some dedicated innovator, you know, some person who really believes that I can change the world with AM, for example. That's where it starts, in the most cases. And then you have to build, as I was mentioning earlier, you need to build knowledge around that. You need to have this training, practice, piloting, and then you need to come to that point where you need to start to do the math and calculate and change language. Because often these people are very into the technology, etc. So what I'm trying to say here is that you don't do that in a day, in one presentation. Usually you have to build it up. And then, for example, having showcases, having a factory where you have implemented all these thoughts, and you have people talking about how excellent this is. This is not the PowerPoint I'm talking about. It's someone...
It's 101.
So I have been trying to implement excellent ideas, and I had an enemy in that management group. And so I didn't know how to come around him, and well, I'm a Swede, so we were in Sweden. But then he went to the US, he visited our factory where we had implemented all these ideas, and he was talking to the American guys. I don't know, there was not so many women there, so but unfortunately. Then he came back, and he became my best friend. And I go, wow.
Yeah, sometimes you need another.
What happened there?
Yeah, another perspective.
But what happened was that he came, he saw, and he was talking to people, and he started to believe. So I think that having pilots and practice is a key to drive the change. And then, of course, you need the numbers. That's the fact base, the paper that the person will point at and say, well, this is what's my ground for this decision. But I think that visit in that factory was the real reason why they changed.
Great example. So you wanted to add something?
Yeah, I would continue. Very, very good points. But also, I think this is one thing that's where this kind of ecosystem can help. So, message coming from expert to expert, and also finding those companies who are tackling with the same problems. So, finding the solutions together, and also taking the message to these C-level guys. So, I think. We do believe in collaboration in that sense also.
I mean, it's what makes, sorry, I have a question for you, so that might fit.
Yeah.
Just one comment. So what I think makes it sometimes difficult, you don't, if it comes to sustainable in general, you don't want to talk too much about the negative consequences, because we hear them every day, like 24/7. So you want to talk about the positive outcome, and the positive outcome is much more attractive to any person. So this would lead to my question, probably combines with the thing you want to say. I mean, I know you know for a few years, and I saw the progress, and I think you have much more ammunition at the very beginning, because at your first presentation at Formnext, you were just explaining how to approach the process of LCA. Now we are much further in the progress.
Sure.
So what are what is the situation today from your perspective?
Well, I think to all of these points, doing the research, the LCAs, the business use case stories, which is quite often more about painting a picture than just the numbers. But we also, for us, for me, I'm here at an AEM event to talk about sustainability, but we're also doing other events that are broader manufacturing and sustainability events to talk about additive manufacturing. Like, we can talk about it all we want here, but we need to be doing more where we're talking to other groups and telling them real use case stories, which is what we're doing as well. And for some of our members, it would not make sense for them to go, a powder producer to go to a general manufacturing or sustainability show and try to explain additive just so they can talk about their product. But we can go, I think, to your point with the networks or the ecosystems, and go and be able to represent your membership and say, let me tell you what additive could do for your business. Let me show you a case of design for additive, of part consolidation and better durability, better management of your inventory, compression of your supply chain, where you can say, let me show you these examples, and create that interest that, you might not be talking very technical, but you can get interest throughout an organization. Maybe the finance people say, wait a minute, we can manage, we can not have all that capital tied up in inventory. I need to know more about this. Tell me about this. How do we do this? What would that mean for us? So then you're starting to get, not just the pushing the information, but now they're pulling it, and that can be super helpful. But, we have to do more of those kinds of things where we're talking to a broader audience.
Yeah, and what I think we need more, let's say, like you did today, so you brought parts. Don't get me wrong, sometimes you need to touch it. Same probably with a visit in the factory, You get the parts in the hand, and everything that you said was not only about functionality, that's the one part, It was all logical. And even someone with no technical background can understand directly, this is how we should do it,
Sure.
So we need more of these stories. Christian, so if it comes to education, the students come to you, and so you teach them how to do that, okay? So are they sometimes asking what is the sustainability aspect about it, or is that something that is not that? Are they more into the technology part, or is it an aspect that is combined or attached?
Yeah, let's say it is to a certain extent combined, but they look at it in a different way than maybe the generation 10 years ago. Definitely, they do look at it from a different perspective. Maybe they are not directly coming in the way that it needs to be sustainable or whatever, but they are asking more questions about it. This is what I really see, and maybe look at it from different perspectives. And actually, today, many of the technical students, they already have a background in 3D printing, because many of them have those small 3D hobby printers at
makers,
home.
yeah.
So there was those small makers, and they changed a lot, because in the past, people studying in our technical field, they were coming from lying under a car and working on it in a certain way, and today they come with small printed parts. So there is, let's say, a visibility of 3D printing for them, and we can use that. I'm pretty sure that the new generation coming into the industry has a much more knowledge about 3D printing just because they bring this. Sustainability is an issue, but it's not the most important one when I look at the technical students.
Absolutely.
That's definitely the case.
This brings me to you, Markus, again, because, I mean, we don't have a similar background, but we're coming from a, let's call it, traditional industry, okay, in a very positive way, but it's very traditional. I mean, it's not only the young students. In our age, we do need to do the mind shift as well, because as we discussed in our skills and talents panel, we have a lot of elder people, or elder in terms of, I would consider myself elder, yeah? So over 40, let's put it over 40. Yeah. So not the 8 years old. So, so how to change those mindset? I mean, you did it. What was your motivation? Or event or experience? Yeah, I mean, you're working now in the field of additive manufacturing. I've seen some of your, let's say, success stories that you present on the RISE homepage, where you are mentioned, but you are coming from the total different world. What made you change your mind? Don't get me wrong. I hope it's not too personal.
Well, actually, it was when I was working with the Lean, and then the idea was to use connectivity to bring Lean into the transport and logistic industry. And then the waste in Lean.
Yeah.
And one of them is
Tim Wood.
Transport.
Yeah.
So that was epiphany for me. So that was so then I realized that okay, we need to do something. But then I took a detour in the manufacturing industry with metal cutting in order to learn the basics. And then 3 years ago I started then with RISE to pursue this question: how will 3D printing change logistic transport and our industrial system? And coming then to the last part there, the change of the industrial system, here we have, in this discussion we've been talking a lot about the supply chain, but then also we have a demand chain also.
Yeah.
So if you can start to decrease the demand, meaning that, for example, having more durable products, then of course that will slow down the pace and the supply that you need. And of course, it will also slow down how much you need from the earth. So being able to keep something alive in the use phase for a longer period of time is an area which I see that AM is a great enabler, because what will happen if you start to slow down the demand is that the volumes are decreasing, and what happens then with factories which are built on mass production? Yeah, so these are research questions, so that's why I transcended into research in order to be able to work with them, because,
That's a fantastic perspective, but brings me to another question, Sini, probably for you. Let's say I'm cutting demand chain because I don't need it anymore, because parts have a longer duration of being able to work, okay? On the other side, I reduce the supply chain. There are so many losers included. That's a little bit my problem, One of the things is convince management. The other one is to prevent too many enemies, because they know that they can't survive it. I mean, remember, we have so many examples in business where companies didn't survive because they were cut off due to technology innovation, and this would be the one. Are there the members where you see their lack of slowing down the process?
Well, our members are AM enthusiasts.
Okay.
Perhaps not that perspective, but I can say that of course the business is not that huge at the moment. So I'm not seeing that as a threat at the moment, but in the forthcoming years perhaps, but we are not there yet. I would say, at least in the Nordic countries. I'm not sure if you are having different kind of situation. What do you think, Sherry?
Yeah,
how
that would
do
be my
you
next
see
question.
it?
Yeah, you know, I think that's always the way with innovation and technology, right? There's always going to be some things that are not needed anymore, whether it's the same volume or the same things. And how you navigate that's always going to be challenging, and there's going to be winners and losers in all of that. I think, you know, we do hear a lot when we're talking about like universities, we say, you know, what is the engineering department doing to have more about additive manufacturing? I'd say, what is the business school doing? How are we working to get additive manufacturing into the business school? I'm working with a university right now, my alma mater, where I got my MBA, and said, hey, I want to look at how does this impact supply chains? And they were like, tell us more about this. They knew almost nothing about this. And so, you know, if we want those people that are in finance and in sustainability and distribution and supply chains and all of that, we can't wait for the engineering department at Volvo to tell all the rest of the company. You know, they're trying to push a rock up a hill internally. We need to be able to help educate the people in these other functions about what these capabilities are. They don't have to know all the technical capabilities. You tell them kind of what it is, but what this can do to impact their area, and suddenly they're very interested and looking at more of that. So, you know, change is always difficult, and you know, there will always be winners and losers in that. So,
but considering the current situation, Sherry, and we don't need to focus on the US, but also it's the same situation as with us. So we are looking into an economic crisis. I mean, it won't be tremendous. I don't know. We will see. Yeah, but it's getting harder now to convince people in this topic. Won't you think? Or could it be a driver?
Around sustainability?
Yeah.
Well, that's why I think you can't just talk about it as sustainability, because you're right. In the U.S., we're not going to hear the words global change for 4 years now. But when you talk about resource efficiency and running your business efficiently, and you know, the U.S. may not be, and I'm just generalizing about the U.S., they may not care about sustainability, but they certainly are concerned about the fact that titanium is all coming from China or Russia. So, you know, there are other factors that are very important. And so, you know, how you talk about this, you know, like I said, you know, for me, using the terms resource efficiency, we can call it whatever you want. We can call it sustainability. We can call it resource efficiency. It's really all the same thing. But, you know, knowing how to talk about this to the right people really matters. Like, I went to a supply chain conference just to hear what these people talk about. What are their pain points? What's the terminology they use? Just like those military people don't talk sustainability, they talk sustainment, which is a slightly different thing, but kind of the same. You know, and being able to talk to those other groups, what are their pain points? How can we help them, instead of saying, I've got a solution to a problem you maybe don't even have. It's like, find out what are their pain points, how can we address it, how can we, you know, what language do we need to use with them, and how can we make progress in that way and educate those folks about what, you know, these amazing capabilities in this building, but we can't wait for them to show up at Formnext. We've got to go to them.
For sure not. So we have 3.5 minutes left. What I want to end the session with, I haven't done it for a long time. Give me 1 or 2 words, Ini. You want to start? No. Now give me 1 or 2 words. What do you think has to be done in order to push further sustainability with additive manufacturing? Just 2-3 words.
I could say that we need facts. And also I would highlight that quite often I think if it's a business case, so environmental and economical sustainability, we are building those hand in hand. So there are any constraints in that.
Very good.
Yeah, when I was a kid, there was 4 billion people on the Earth. I looked it up today. It's 8 billion today during my life, and you see how young I am. So thinking of that development, which is hard facts, and then you draw the line, and then so are we going to be 16 billions And how much resources are all these people going to consume? So I would say that virgin materials should be super expensive.
Yeah.
Because if it's expensive to get virgin material, what will happen then? Then will you start to reuse. And then, as we said here, then keeping something alive decrease the demand for virgin material. So
very good. Christian.
I think fact-based and holistic cases that really show that sustainability is something we don't need to do to being more sustainable, but to also being more economic in the end. I think this is really the fact that we see now. And I agree with you that we don't yet have enough of those cases, but we need to have them in order to show them and convince people in the whole supply chain.
Yeah, very good.
And I absolutely agree. We need more accurate data for all the vendors in these buildings. They need to be able to provide data so that we can get a good analysis. But we need more complete business case studies, not just the part, but looking at the impacts across the entire business. And the more we can put those out, I think will be valuable for everyone.
Oh, that's a majority. I like that very much because this brings me to my closing words. Thank you so much, the four of you. Very fruitful, vivid discussion. I loved it, to be honest. My favorite one so far. Thank you so much. That was really a pleasure. And for you, the audience at the live stream, here comes an economic hint, okay? And that's the key takeaway out of this panel discussions. Go and make LCAs. Go and make and find the real cases where we can present it to your customers, to your suppliers, to you yourself, to your management, in order to push the topic and basically not only doing something for the environment, but also doing something for your resources, because that's what it's all about, because they are limited. So it was a pleasure to have you. You will get another few minutes of highlights to enjoy, and afterwards we're coming to a real highlight of our fair. This will be, this will be our Formnext Awards celebration. So stay tuned, wait another few minutes, and then we are back here with a ceremony of giving the awards away. Thank you so much. Stay tuned.
Richtig große Metall-3D-Druckbauteile, wo kann man die eigentlich sehen in der Fertigung? Zum Beispiel bei Audi in Ingolstadt. Und wir sind das erste Kamerateam, das sich das anschauen darf. Hallo Herr Spindler.
Hallo Herr Blonski.
Schön Sie kennenzulernen.
Schön, dass Sie kommen, um unser metallisches 3D-Druckzentrum zu besichtigen.
Was genau machen Sie hier mit additiver Fertigung bei Audi?
Zum einen entwickeln wir die Technologie weiter, neue Werkstoffe, zum anderen stellen wir Betriebsmittel her. Entweder weil wir dadurch über Lifetime des Produkts, des Betriebsmittels Geld sparen, oder weil wir Themen herstellen können, die anders qualitativ so gar nicht herstellbar wären.
Mhm. Spannend.
Ich führe Sie jetzt zu unserem Projektleiter, dem Herrn Bock, der Ihnen etwas zu unseren Betriebsmitteln zeigen wird.
Oh ja, sehr gerne. Freue ich mich. Hallo Martin, schön, dass du Zeit für mich hast hier im 3D-Druckzentrum. Ihr produziert ja hier Werkzeugsegmente für die Fahrzeugproduktion. Was genau produziert ihr hier?
Also ein Anwendungsfeld für die additive Fertigung sind Werkzeugsegmente für die Warmumformung. In der Warmumformung legen wir Blechplatinen mit 850 Grad Temperatur in ein Werkzeugsystem ein. Hier ist eine solche B-Säule von einem aktuellen Fahrzeugprojekt. Wir formen das innerhalb weniger Sekunden um und vergüten dieses Bauteil.
Und was hat das dann für einen Nutzen, dass ihr das mit so einer hohen Temperatur macht?
Durch das Vergüten erhalten wir Bauteile, die leicht und stabil sind. Gerade in solchen Bereichen und in solchen Fahrzeugkarosseriebauteile ist es wichtig, dass hier Stabilität vorherrscht. Ein Beispiel. Hier habe ich dir mitgebracht, ein Demoteil in Kunststoff gedruckt, damit man das sehr genau sehen kann, wie das Bauteil hier in diesem gesamten Werkzeugsystem eingesetzt wird und hier mit konturnah geführten Kühlkanälen ausgestattet ist. Ja, diese konturnah geführten Kühlkanäle führen zu einer besseren Temperierung und zur Einhaltung geforderter mechanischer Eigenschaften des Endbauteils.
Kann ich mir das mal anschauen, wie ihr das macht?
Na klar.
Ja?
Dann komm einfach mal mit.
Okay, cool. So Martin, das ist jetzt hier eure neue Maschine also?
Ja, wir haben in Metall-3D-Druck investiert. Größerer Bauraum, Mehrlaseranlage, modular aufgebaut und mit einem hohen Automatisierungsgrad versehen. Wir wollen natürlich das ganze Thema Metall-3D-Druck weiterentwickeln. Das ist für uns jetzt die nächste Stufe. Bauteile sind in den letzten Jahren eher größer geworden von den Dimensionen. Deswegen auch hier 420 x 420 mm Bauraum. Wir wollen das Thema manuelle Einbindung des Werkers, die notwendig ist, reduzieren. Deshalb auch automatische Absaugung. Und dann auch modular die Anlage gestaltet, dass wir sie später erweitern.
Okay, und was ist mal Stichwort Kosten, weil so eine Maschine ist wahrscheinlich relativ teuer. Wie sieht es dann mit den Stückkosten aus für euch?
Teuer ist die Maschine. Wir werden jetzt im Detail untersuchen, wie sich die Stückkosten tatsächlich entwickeln. Aber ein großer Teil bleibt natürlich noch im Kostenblock. Das ist die Stützstrukturentfernung. Und das glaubt uns eigentlich keiner immer in der Branche, dass das aber ein großer Punkt ist, warum wir noch solche Gründe haben, nicht in die Serienfertigung zu gehen mit Metall-3D-Druckteilen. Und jetzt kommst du mal mit und jetzt zeige ich dir das mal, dass du das mal verstehst,
okay,
was das
gut.
bedeutet.
Ja,
okay?
Lass uns mal schauen.
Siehst du, Frank? Ganz schön anstrengend, ne?
Das ist schon ein harter Job, muss ich sagen.
Ja, Übung macht einen Meister. Da musst du noch ein bisschen üben, glaube ich. Ja. Aber ich hätte gesagt, gehen wir mal raus, gucken uns das Formnext-Programm an, schauen mal, was es da Neues gibt.
Ja, das ist auch eine sehr, sehr gute Idee.
Ja.
Mensch, Martin, vielen Dank. Das hat wirklich heute sehr viel Spaß gemacht. Ich habe viel gelernt, aber es war auch echt anstrengend.
Ja, also war sehr schön, dass du da warst. Wir haben dir einen Einblick gegeben, wie wir additive Fertigung sehen im Metall-3D-Druck. Ja, ist ganz schön anstrengend an der einen oder anderen Stelle, braucht auch Zeit. Und ja, das ist so der Punkt, wo ich sage, da freue ich mich auf die Formnext und viele neue Themen und Lösungen, die dort gezeigt werden.
I came from the mud. There's dirt on my hands. Strong like a tree. There's roots where I stand. Oh, I've been running from the law. Hope they won't shoot me down soon. They sing on a sleepless night. Try to catch me howling at the moon. 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 rose up to my chin. Won't stop fighting to the very end. Many men try to reach it. Many men have failed. Well, if you wanna get to heaven, you gotta raise a little hell. And I've been running from the law. Facing on a sleepless Will you find me? Hope you find me. I'll be back home soon. When the sunrise, when the sun.
Time's up for traditional industries. Watch out for AM.
Welcome to Formnext Livestream. Welcome to Formnext 2024 Award Celebration here in Hall 11 D72 at Formnext 2024. Here at a trade show like Formnext, we are witnessing a flood of innovations, new products and services. Our live stream, along with numerous products and services, videos, and we saw clearly reflected this dynamic of an exhibition like that. With such a wide variety, it is essential to discover and highlight standout developments. And what better way to do that? By presenting an award. Today, we are very, very proud to present 6 new Formnext awards. Let me name them. Sustainability Award, the Ambassador Award, the Revolution Award, the Design Award, the Rookie Award, and the Startup Award. Now, I would say let's hear from the creators of Formnext about why these categories were chosen and the reasons behind the updated concept. Sascha Wenzler and Matthias Missling from Formnext. Please join me on stage and a big applause for these two.
Hi, Frank. Hey.
Hi.
Good to have you here. Hi.
Hi, Matthias.
Nice to see you.
Yeah, come. One right, one left.
Great.
Sasha.
Yeah.
Why an award for Formnext, and you changed the concept, as I mentioned. What was the reason behind?
Yeah, we framed it a little bit, Frank, and let me just say a very warm welcome to everybody here on stage and on the screens as well. And hey, they look really nice. They look beautiful. And yeah, we are just about to finish the third day of Formnext 2024, and you know, the additive manufacturing community, the industry, turned out again to be fabulous, fantastic, because it's an important event in let's say, challenging times and a challenging environment, and you can feel it again in all of the halls, and I think you experienced it as well the last 3 days. It's a positive impulse taking place here in the halls, between you guys, between the exhibitors, the visitors, and again, connecting the community and giving a positive impulse also for the coming future. And that brings me to the awards. Why? Because finally our main job as an exhibition organizer is to bring an audience together, to bring attendees together, and to support the know-how exchange, to transfer the knowledge, and to connect also, let's say, generations.
And to bring on stage, right?
And to bring it on stage.
But let me bring in Matthias.
And that would just be the perfect moment to hand over to my colleague.
Because Matthias was the one who selected who will be brought to stage.
Exactly.
Not at the end, but you choose the finalists. Or what was the method to choose who will be finalists?
Yeah, certainly. First of all, thank you very much for all these great submissions that we got in each of the 6 different categories. We had a big variety, and we were really amazed by the quality and by the variety of the submissions. Thank you very much to all the jurors who have done a great job, who were also amazed by
the jurors. They helped you to collect all the ideas.
Absolutely.
And all the submissions. Okay.
Yeah, exactly. We got the submissions, numerous submissions per category, and then they've chosen the finalists. So now we have the finalists here, and everybody is keen to know who's finally the winner.
And we will, as we will see later, we have laudatoren for each category. Why that? What was the idea behind?
Yeah, it's important to get also a feedback of the importance of the category for the whole industry. And as we have 6 different categories, there's all variation in there. And yeah, the laudators will talk about the importance. Yeah.
And these are again what you meant, the hook between the new concepts and the old one, because there are some really well-known companies supporting the award as well.
Exactly. So we have prominent cooperation partners, we have prominent sponsors, and yeah, the idea behind is to connect also the winners finally with the industry, and it's perfectly symbolized, like Matthias already told. It's perfectly symbolized by awards at the end.
We have some seconds left. Can you tell us who made the award? Because we already said it's a really very nice piece.
Yeah. Yes, thank you very much to Suto, the artist couple from Hamburg who designed the award. And thank you very much, a big thank you to Voxeljet for the production of it.
Okay, yeah, thank you very much. So we have sorted it out, but now I think everybody wants to start into the award ceremony. Thank you both. You're staying with us, and we will meet later.
Okay.
And I think you don't know who has won yet still, right?
No,
so
it's still, for me it's still a secret,
the only
enjoy.
Man who really knows it is here standing right before you. Yeah, let's start into the first category, Sustainability Award. And now let me introduce to you the honorary speaker for this category, Rainer Lotz.
Thank you very much.
Good to have you here, and you have brought a laudatio with you. So let hear, you have
So, Renishaw.
3 minutes and go.
Oh, Renishaw and sustainability. This is rather 3 hours, I would say, but I guess I don't have the time. So I think it's very important to have this category because sustainability is something we follow a same goal, I would say, all of us. We have one goal, we look for similar targets, and it's the industry, it's research, and we also need groups, platforms, associations working all together to benchmark what can be done to improve sustainability all together, to be fast enough to have an impact. I think that's very important, and it's also part of our company history in the last 50 years in Renishaw. Who is Renishaw? Probably 1 minute about us, who we are. We create high precision technologies for manufacturing, analytical instruments, and healthcare. Around manufacturing, we offer systems and components for complete precision control, reliability, increasing productivity, and sustainable manufacturing processes. Since over 50 years, we live sustainability in all ways in our company. It's a vital part of our company philosophy, and there are many ways where sustainability is of great importance. So it's in our own operation, in our own organization, our technical resources, our human resources. It's our impact on the environment, of course. Our impact on the community around it is very important. And we have, since over 50 years, a philosophy behind that for continuous increasing productivity, for high competitiveness, of course, we have to stay alive, and for sustainability. That's very important. Last but not least, of course, our products. We have many patented products, and those products increase sustainability of our customers. And that's the real way to scale it up in the world. We supply those all over the world, and we make manufacturing of our customers sustainable, not only with metrology and in metal cutting technology, also in AM. It's very important to be highly productive, knowledgeable, to use AM, of course, in a way that it supports sustainability in a company. So honestly, the topic, Frank, is as wide as you can imagine, and of course we could talk several hours about it, but it's also as colorful as our finalists, I would say. So who is the winner?
And yeah, not so fast.
Oh,
not so
sorry,
fast.
I'm so...
I want to add sustainability. When we were looking here at our presentations on stage and the panel discussions, you know, you had a totally different topic, and then pop, the aspect of sustainability came up.
Absolutely, it's not one-dimensional. You know, there's so many dimensions.
And that's in the DNA of additive manufacturing, I think. And everybody brings it here to stage. And so we are very happy that you are the sponsor of this award.
So are we.
So thank you very much, Rainer Lotz. And now I think it's time really
what
to
I didn't
bring.
know is that we hired him recently. That's nobody told me. Christian, where are you? Is he still around?
That are the small surprises here.
Oh, thank you.
So now let's bring our finalists and the jury representative on stage, please.
Baker Hughes is using additive manufacturing to reduce the environmental impact of gas turbines. By replacing casting methods with LPBF technology, they improve efficiency, reduce CO2 emissions by 38%, and support their goal of achieving net zero emissions by 2050. Ceratizit developed an additive manufacturing process for cemented carbides used in cutting tools and wear parts. Their FFF process reduces CO2 emissions by over 95%, allowing for inner hollow structures. With 100% renewable energy and reprocessed materials, Ceratizit leads sustainable manufacturing. Stratasys promotes sustainable luxury footwear by reducing emissions, conserving resources, and lowering costs. A recent study shows that 3D printing reduces emissions by 25%, material usage by 49.9%, and even electricity consumption by 64.3%. The J850 textile is highlighting additive manufacturing's sustainability potential.
Okay, then let's find out. I know the person who knows. Oh, the winner of the Formnext 2024 Sustainability Award is Serhat Titzit. Congratulations. Congratulations. Come. Come. Take a photo. Come. Show the photo. Okay. Thank you very much, guys. Congratulations. Congratulations. And I wish you a lot of fun with the prize. And with the money as well. Now, let's unveil the second category, the Ambassador Award. No need to introduce him, but I will do so nevertheless. Sven Krause, he's not here as a moderator. He's here as honorary speaker for his category. Sven Krause, the category Ambassador Award. Your laudatio, please.
Thank you so much. So first of all, let me express what an honor that is to do the laudation for such a very important award. All the awards are very important. The Ambassador Award is in my specific, because we discuss it all the days here, how important it is to spread the word of additive manufacturing. So let me read my laudation. Ladies and gentlemen, it is a true pleasure to present the Ambassador Award. This award honors individuals, organizations who have made a unique impact on the industry, our industry, and its users through innovative training, educational initiatives, or personal advocacy. This year's finalists have demonstrated exceptional passion and dedication, and I confirm that, bringing additive manufacturing to a wider audience and driving the industry forward. The nominees are Stanley Tang. He developed a company-specific curriculum for additive manufacturing, built a network of experts, and made the technology accessible to thousands through his lab. Congratulations. And we have 3D printing nerd. No need to introduce him. Through his entertaining YouTube show, he educates a global audience about additive manufacturing and shows how everyone, including me, can be part of the next industrial revolution. And last but not least, the University of Stuttgart. In collaboration with dentists from the University Medical Center Freiburg, they developed innovative dental bone implants using additive manufacturing. These individuals and organizations exemplify the passion and innovation that drive our industry forward. They are true ambassadors for additive manufacturing and deserve our highest recognition and, of course, your applause.
Thank you very much, Sven. I would say it's time to bring our finalists and the jury representatives on stage.
3D Printing Nerd is a YouTube show hosted by Joel Tellen, exploring the world of additive manufacturing in depth. With expert interviews, tutorials, and demos, it makes complex 3D printing technology accessible and fun. It educates a global audience about the future of manufacturing Stanley Tong has been pivotal in driving additive manufacturing adoption at a major vehicle manufacturer. His tailored training programs and expert network have made 3D printing accessible to thousands. This has ensured its integration across all levels and boosted AM adoption within the organization. The University of Stuttgart, in collaboration with the University Clinic Freiburg, developed innovative dental bone grafts for treating bone defects. Using ceramic-filled resins and precision implants optimized for DLP stereolithography, they advance bone regeneration, expanding additive manufacturing's role in dental care.
Who will take home this award? Let's find out. Is it the right one? Yeah. The winner of this year's Ambassador Award is AM of Bones, University of Stuttgart. Congratulations!
All of us?
We want to take a picture. Thank you. Congratulations and a lot of fun with the prize. Yeah, very nice. It's a good job, yeah, to give away something like that. It's really fun. But now, let's move on to the third category, the Revolution Award. And now let me introduce the honorary speaker for this category, Oscar Milani. Oscar, the laudatio time runs now.
Thank you very much, and it's a real pleasure to be here on behalf of 3D printing industry to present the Revolution Awards today, celebrating groundbreaking advancements and innovations which are really pushing our additive manufacturing industry forward in new and exciting ways. For us, the importance of the Revolution Award is the recognition of those companies and organizations who are leading the charge in changing the AEM landscape and challenging the status quo and pushing and reimagining technologies in ways we have not seen yet. So the contributions to this award are not merely incremental improvements to existing technologies, but rather, as the name suggests, revolutionary new applications and solutions for the AM industry. So the three finalists this year are AM Systems with their multi-patterning laser module, capable of boosting productivity and maintaining high resolution with resin printing. Next, we have Fraunhofer's multi-material processing for powder bed fusion printing for productions of battery cell housings and other complex structures using many materials like ceramic, metals, and others. And finally, a efficient support removal system by Toolcraft, utilizing dry ice blasting systems, cutting down bottlenecks and increasing capabilities in the post-processing sector. So thank you.
Yeah. Thank you, Oscar. And an applause for you. And then we will have the finalists and jury representative on stage, please. Come and join us.
AM Systems innovates with its multi-laser patterning module, combining multiple laser beams for high resolution and productivity. This scalable module delivers precise targeting at 20-micron spots, paving the way for the next generation of high-quality, high-volume industrial 3D printing technology. Fraunhofer IGCV developed a patent-pending powder bed fusion process that produces battery cell housings from aluminum, copper, and ceramic in a single step. It simplifies production, offering design flexibility and faster prototyping, which accelerates the development of advanced battery technologies. Toolcraft created a dry ice blasting system to remove support structures from metallic 3D printed parts. This semi-automated solution improves production efficiency, quality, and ergonomics. It reduces cycle times by 15 minutes per part and streamlines production. Additionally, it enhances the work environment.
Then let's find out who the winner of the Category Revolution Award is. The winner of the Formnext 2024 Revolution Award is Fraunhofer IGCV. Congratulations. Come. Take it. Let's take a picture. Congrats. Thank you very much. Have a lot of fun with the prize. What? Yeah, I would say we move on to the next category. And the next category on my page here is a design award. We are very happy. And now let me introduce the honorary speaker for this category, Thomas Lück. Thomas, it's good to see you. It's good to have you here. I don't want to take time from your laudatio. We are curious about what you have to say, why design is an important topic and worth for having an award.
Thank you very much. Welcome. AM and design, perfect fit. And therefore, I believe for me, it's the most important category of the afternoon. Why design and EM and why me and why ZURB? So, few seconds advertorial. ZURB, we are doing additive manufacturing for 30 years. Our 30th anniversary this year, exhibition, a booth in the other hall. And so we see additive manufacturing, its development, even if we had not the name additive manufacturing at the very beginning. We called it rapid prototyping at that time. Now for all that 3 decades. And with the hype around 2010, 2012, we saw more and more that it was not just prototyping for design as well. It became more and more that people talked about products. It was a time of the first printed car, the first printed house, and so on. And we thought, okay, we want to see it, we want to be part of it, but we also want to push it. And that way, we created a design award for additive manufacturing in 2012, which was the Pomundus Challenge. And we had that, we're celebrating, and really nice award winners for 10 years, in a very good collaboration here with Formnext over the last years. And now, I believe it's really the exact right successor that we have it now integrated into your complete design, your complete AM award categories. So therefore, for us, it has a long history. We always have been addicted, affected with design. We believe additive manufacturing opens a whole new world what you can do design-wise. But it should be something reasonable. So for this category, we want to see products. We want to see products which are really well designed, good looking. You want to have them. And we want still responsibility. So sustainability, as we saw, and other things should be still kept in mind, not just something good looking. And we see many areas where products are created now with additive manufacturing for one-off, for customization, and so on in totally different areas, B2B, B2C, and the finalists this year are really widespread in these different areas, as widespread as the applications we see in our day-to-day business. And so if I look at these finalists, the first in my mind, without judging the different the first in my mind comes from Siemens, called 3D Process. Sounds like it's a process to 3D print. No, they use 3D printing to do something for the chemical industry in a very, very clever way. But it wouldn't be right in the design category if it would not look good as well. So is it something you want to have? Not sure if my girls at home like me to create some chemistry in our living room, but if it would sit in my living room, it wouldn't spoil it, it would enhance it. So right in our design category, and it's quite sustainable. You will see a video in a second about it. The second is a medical application. So it's in the orthoseptics area from the company Quorum. They call it Quattro. And on the first side, you say, oh, well, that's not the first in that area. We have seen others beforehand. But it's done very clever. It looks absolutely good. And you know, if somebody has unfortunately only one leg and needs an artificial leg, probably we with two legs are difficult to feel into that. But I learned it's difficult to put on. It's difficult to make it really fit. It's not just your geometry, and also it develops. The rest of your leg develops over time, and the adjustment is really difficult. And they combine something quite clever in lattice structures, what we at SURB love as well. If you see, I have a lattice structure bicycle helmet, for example. So in lattice structures, they integrated something like we know maybe from skiing boots into their product. And that total, we found it very clever, well designed, good looking, so worth being in here. And the third group comes again from a total different area. They come from architecture. It's the University of Stuttgart. Two institutes worked together. And it's not just 3D printed what they do. It's really, again, a process chain. They print the mold to make an architectural structure and then cast that. And this mold is 3D printed, but very sustainable with reusing all the shell and everything. So 3 really good finalists, and I'm curious to hear just after the videos who has won within these 3. Thank you for having your time.
Thank you very much, Thomas, for the explanations. And now I think it's time to bring the finalists and jury representative on stage and have a look at the solutions.
The ILAK and ISW Institutes created the Marinaressa Coral Tree, a lightweight concrete structure showcased at the Venice Architecture Biennale. Using 3D printing for recyclable, water-soluble sand formwork. It saves 60% material use with no waste, supporting sustainable construction and decarbonization. Quorum Orthopedics developed the Quattro, a revolutionary prosthetic socket that offers enhanced comfort and adjustability. Using MJF printing, it features customizable volume and modular structure, making it easy to fit even with swollen limbs. It's a sustainable solution transforming prosthetics. Siemens, with the 3D Process Consortium, is transforming the chemical industry using AM. By creating optimized reactors with complex geometries, Siemens reduces energy use and material waste. This approach accelerates development and makes chemical production more sustainable and efficient.
And I would say it's time to reveal the winner. The Design Award 2024 of Formnext goes to Siemens 3D Process Consortium. Congratulations. It will be team pictures after this, but one first picture for exhibition photograph. Perfect. Thank you very much. And best greetings to the colleagues who made this happen. Yeah, we already proceeding to the 5th category. So I'm very happy to introduce the Rookie Award. And again, Sven Krause with me to presenting the laudatio of the Rookie Award. Sven, the stage is yours.
Thank you so much. So, ladies and gentlemen, it's my honor to present the Rookie Award today. Let me quickly explain what that is. This award celebrates individuals with promising business ideas who have either not yet founded a company or whose startup is less than 1 year old. And before I proceed with the laudatio, let me tell you a personal story. When I stepped into the industry, my first task was to moderate pitch events, okay? So you see all these promising startups, and some of them were horrible in their presentation, some of them were great, but the main thing that I took out of it, it was so amazing to see how they developed over time. Today, a few of the biggest exhibitors here on Formnext have there been like 10 years ago on my stage, and I was like, oh my God, that was a horrible presentation. And nowadays they're so huge, so sometimes the presentation says nothing about the quality of the idea, the innovation, the product. I'm so happy that we have that Rookie Award, and I can tell you, I had them all on stage, and presentations were awesome, as well as their solutions, so I'm more than happy to announce the finalists. So this year's finalists have impressed us with their innovative approaches and dedication to advancing additive manufacturing. Let me present them. So we have Enki Interdentalis, which will save my problems. Yeah? They developed a 3D printed custom-fit dental tool that uses a water-air mixture to improve oral hygiene by removing food particles and plaque between teeth. Awesome solution. Then we have Fidentis. This startup introduced a multi-material additive manufacturing solution with an integrated robotic arm that creates prostheses based on digital models. Very great. Then we have Oryx Medicals. They are developing an innovative, additively manufacturing aortic valve that could revolutionize the treatment of aortic valve stenosis. And I tell you what, these outstanding contributions, they highlight the potential of the next generation of innovators in additive manufacturing. They inspire us, at least me, and I think all of you as well. Think beyond the limits and actively shape the future, our future. So, the finalist, Frank, thank you.
Sven, thank you very much for the laudatio and for your story. Behind in the office, yeah, it's always the same. We are telling us stories from our home, and you know, it's a very funny time, I must say. Formnext is always a pleasure being with you.
Thank you so much. Thank you so much.
Yeah, but now back to business here. Hope everybody is still there. And now let me introduce, that's what's also the right place. It's time to bring the finalists and the jury representative on stage and to our video stream.
Anki Interdentalis developed a 3D printed dental splint that uses a water-air mixture to remove plaque from interdental spaces. Designed from a patient's scan, it generates microdroplets that clean all interdental spaces in just 3 seconds, improving dental care for both professionals and patients. Fidentis offers a multi-material additive manufacturing solution for dental prostheses. Using the metal powder bed fusion process, it combines alloys such as cobalt chromium for strength and gold for precise fit. This robotic process ensures high quality, dense parts and enables efficient, precise production of dental restorations. Oryx Medicals is developing a 3D printed aortic valve for treating aortic stenosis. Unlike mechanical valves, it uses a minimally invasive TIVI procedure for easier implantation, tailored to each patient's anatomy. The valve combines durability with a longer lifespan, reducing recovery time and complications.
Then let's find out who has won. Are there some nervous faces on stage? No. Finally, the winner of the Formnext 2024 Rookie Award is Oryx Medicals. Congratulations. Now let's take a picture. Let's take a picture. Come closer. Thank you. Thank you so much. Have a lot of fun with the prize. Yeah, time runs fast. We are moving to the last award for today. And now let me introduce to you the honorary speaker for this category, the category Startup Award. It's Arno Held, a well-known man here on stage and in these halls. Arno, it's very good to have you here.
Thank you for having me.
You have 4 minutes for your laudatio. The stage is yours.
Thank you so much. Good afternoon, everyone. Having an idea for an invention takes skills and a very high level of competence in a very narrow niche. But taking this invention, turning it into a product that generates commercial success for investors, for customers, for employees, that builds a company to employ people, to have a lot of success for entire families and a high impact on society, this is entrepreneurship. And that not only takes skills and competence, that takes a lot of guts. This takes a lot of conviction. It takes a certain level of naivety, for sure, because every single founder that I've spoken with in the last 10 years said, had I known what was coming at me, I would not have done it. And it's good this way. It takes a lot of guts. And I envy every single entrepreneur that I have met on this journey for this courage and for these guts. I'm Arno Held. I started AIM Ventures 9 years and 11 months ago. And on this journey, I've witnessed 2,870 startups with an idea, taking money from investors, from their own pockets, and building companies, setting up on the journey, facing this competition out there, the harsh winds of reality to commercialize the products. Many have failed, many have become extremely successful, but every single one of them has contributed to this amazing industry with some crazy innovations that have generated a lot of fun, a lot of color, a lot of passion, and a lot of commercial success for many people. So we as a jury, that's exactly what we want to reward. We want to reward the courage, and we want to say thank you. And this also comes from the bottom of my personal heart. After almost 10 years of doing this job as a venture capitalist, I'm still convinced that I have the best job in this industry. I love every single day because it's full of chaos, it's full of inspiration, and that's because of these entrepreneurs that have the guts to set sails into unknown waters and generate something extremely cool, and getting a lot of well-deserved success. And that is exactly what we wanted to look at as a jury. We want to not only reward an invention, an innovation, we want to reward this courage and this contribution for society. So we want to see exactly that impact that you guys could have with your idea and with your business. What is the potential to build a scaling organization, right? It's not necessarily about a single product. It's what can you achieve with a company that you want to build? What is your vision to change not only this industry, but to change this planet? Because that's the one conviction that I have come to in 10 years of AIM Ventures. This planet will not be decarbonized without the help of additive manufacturing. And I'm deeply convinced that it's startups that are going to change this and not the big guys. Because the one advantage that the startup entrepreneurs have is you can not only design products for additive manufacturing, you can design companies for additive manufacturing. The big incumbents are designed on conventional manufacturing technologies, and they have to shift their tankers around into the direction of digital manufacturing technologies and new ways to produce. The entrepreneurs are designing entire companies for additive manufacturing, and this is the great contribution to our industry. So on behalf of the jury, on behalf of the entire industry, thank you to all founders, startup entrepreneurs that have submitted an application. It was so much fun to review the whole lineup of applicants. And it's going to be even more fun to reward this with a big check that we have standing there in the corner. Thanks a lot.
Thank you, Arno. And this is the only category with 5 finalists, because there were so many submissions, right? And so many good submissions.
It was extremely hard to pick the winners. They were all really cool, and I said it before. I've seen a lot of startups in the past 10 years, especially, and I'm so amazed how, especially the Formnext team, somehow manages to amaze us and surprise us every year again. And there's something that I haven't seen before, and that's what makes it a lot of fun.
Yeah, perfect. Now, I would like to have our finalists and the jury representative on stage and on our screens. Please join me.
AM Craft is an EASA certified supplier from Latvia specializing in polymer additive manufacturing. They provide 3D printed interior components for aerospace to solve supply chain issues, backed by a global production network that ensures timely deliveries. Their digital warehouse enables the instant reproduction, solving future challenges as they arise. AMSite revolutionizes quality management in industrial 3D printing using its AI-powered software solution. By automating tasks and optimizing processes, AMSite reduces quality management costs by up to 70%. With its streamlined approach, it sets new industry standards for both efficiency and cost-effectiveness. Axolotl Bioscience created tissue print, a xeno-free bio-ink designed for 3D printing human tissue models. It ensures 90% cellular viability and works with a variety of delicate cells. Compatible with multiple bioprinters, tissue print saves time and reduces costs, offering a reliable and easy-to-use bioprinting solution. Microfactory specializes in resin-based SLA 3D printers with fully automated MSLA machines. These printers simplify printing, washing, and post-curing. They deliver precision, speed, and flexibility for dental models, audiology, and more. Cloud connectivity and scalable automation make production more efficient and reliable. Supernova Additive offers viscous lithography manufacturing technology capable of processing materials with viscosities up to 1 million cp. It enables cost-effective production of short and mid-sized batches without the need for costly molds. VLM unlocks new material properties for industries like automotive and aerospace, using both rigid composites and elastomers.
Yeah, now that is a question. Who will be the last winner today? Who will take home the last award for today? Let's find out. The winner of the Formnext 2024 Startup Award is Axolotl Bioscience. Congratulations!
Oh my God.
That looks like we have a party here right now, huh? Isn't it? So I want to have all the finalists on stage. All the finalists on stage, please. All the finalists come to me on stage. And first, Sasha.
Finalist, not a finalist. Not a finalist.
You're the finalist, but the
rookie.
Do you get the photo already? Okay, perfect. So, Sasha, how is you feeling?
Hey, absolutely amazing. You know, it was absolutely a secret about the winners.
Yeah, I was the only one. That's not true, but it sounds good.
But for me it was absolutely a secret. And let's say it like this, you know, congratulations to the winners, congratulations to every participant, and I think the biggest winner is the AM industry and the AM community coming together and some new faces coming in. So that's really the celebration.
Yeah.
It was a great ceremony. Thank you.
Thank you, Sasha. Thank you for making this possible, for bringing this idea here and these innovations on stage. And you know, we have a really good day today because we have a last day of Formnext tomorrow, where we can watch all these, where we can go to the booth and have a look. We can chat to the people. So who wants to make contact? You know, look at the faces, and then you can make contact, and then you can have your direct solution. Now, that is an end to our celebration in our live stream. I think we will do a bit party here with all the guys and all the winners and all the finalists, because everybody is winner here on stage. And thank you very much, the audience, for watching at the screen and here in the hall. See you again tomorrow morning in the live stream at 10 o'clock here in the hall at 9 o'clock. And then we will celebrate the last day of Formnext 2024 together. Thank you very much.
Enjoy. Okay.
Stick it